if they want. Wait, this is my screen, data science and AI for decision makers. Yeah, okay, perfect. So we can get started. Let me maximize this. Perfect, so welcome everybody. A bit of history. Yeah, so this workshop, we have been running this successfully for what it is now about 3 years. And these are some nice pictures from past events. And really, we had many different people from in all those events, from entrepreneurs to CEOs of large organizations, to investors. Here's an interesting group from China that was on a trade mission in the UK, and that's me at the US Navy. Actually, it's a military base. It's a Navy base around Washington, D.C., where I ran this workshop for around 30 people involved in military intelligence. These photos are from St. George One, for those of you who are based in London. It's around Blackfriars. And really, this workshop has helped many, many people all over the years. And the original goal of the workshop was to educate those who don't know about data science and they want to start using data science, to educate them about the topic, right? And the target audience was the CEOs, executives, managers, this type of people. But eventually, what we realized was that education itself is a bit restricted in the sense that you don't want to just educate people, you also want to make sure that they take action, right? And then the workshop pivoted to something more interactive, and as well as the company's mission, where the company's mission is to enable decision makers, whether we're talking about CEO, manager, or entrepreneur, to use, someone wants to join, to use AI and data science, right? So this is the goal of the workshop. And then the workshop pivoted to something, as I mentioned, more interactive. So essentially the goal is to make sure that everyone, the goal of the workshop is to make sure that everyone involved gets something out of it. Whether for some, this might be simply education, for some other people, it might be a very concrete action plan about something like data strategy. Okay, and I like the analogy of AI superpowers, as I call them, where through this workshop, I hope that the people participating are going to get an understanding of data science and AI similar to mine, and I've been involved in this area for 10 years, right? So, and it's not a technical workshop, so the understanding is not at the level of how this algorithm works or how this other technique works. The understanding is on the level of how can I apply data science and AI in my business or in my particular use case. And this also, and for this reason, we also have come up with this term, which we call data science coaching, which is a bit like business coaching, but for data science, right? So essentially the goal of the workshop is no longer to simply educate you, but for me to also act as a coach for you. And obviously we then provide other services as a company in order to support this process beyond the workshop. So there are 5 sessions on this workshop. The first one is the introduction to data science, which is a historical overview, probably not a very actionable session, but everyone who's been through the session, they found it very enlightening because it helps them find many of the buzzwords and the jargon used. And then data management from a decision maker's perspective. The workshop always takes a non-technical decision maker's perspective, so we're not going to deal with any technical topics unless you really want me to. Thinking like a data scientist without being one, hiring and managing data scientists, and finally, how to build the right culture for data science. So, oops, like for some reason, I forgot to completely, wait a second. I want to write the sentence here, and for some reason, I missed it. So what I was wanted to say here is that the main goal of this workshop is to come up with an actionable plan, right? And a challenge that we're facing with this current workshop is that it's online, right? So for like 3 years, this workshop was a day event held in London. And when, like in a regular day event, there's a certain flow, right? So people can speak to each other, we would have regular breaks, You get more direct feedback from the participants. We also had catering, which was a plus, I guess. But then we realized that, unfortunately, the lockdown has lasted more than everyone would expect. So we decided to turn this into an online workshop. So obviously the challenges with online workshops is that, and online events in general, is that many people suffer from Zoom fatigue. Also, it's not easy to, Hubert seems to agree with me about the Zoom fatigue. Yes, I'm super Zoom fatigued as well. I made sure that today I would have fewer calls than regularly because of the workshop. And again, it's not easy for me to get feedback, direct feedback, so you know what people are doing behind their screens. So there is the possibility that depending on how the session goes, we might not go through the full workshop today, and then we might go through the full workshop next week or the week after. And obviously we're going to run something like a doodle poll to find a time that's convenient for everyone. And also if we run an extended session, there's a chance to also bring a guest speaker on a related topic, probably around product management for machine learning products, most likely. And again, the reason why I suggest doing this is because we are, as a company, more goal-driven than, so our goal is not to simply educate you, but we want you to achieve your goal, whatever these might be, right? From starting a new company to growing an existing company to simply understanding what AI and data science is. So if we see, for example, that, yeah, 4 hours is not enough, or we see that everyone's pretty tired hearing me speaking after 3 hours, then we're just going to run another session, because that's an experiment for us as well, running this for the first time online, and we want to make sure that everyone's happy. So that being said, before I start the first session, I would kindly ask everyone to do a 1-minute introduction of themselves. The reason being that, you know, we're now virtual, we can't really see each other, and this is a bit unfortunate. I mean, we can see that on camera because the workshop in the past has also been a great networking experience for many of the people involved. So I guess I'd like to try and replicate a bit of this experience. So if you could share 1 minute about what you do and what you'd like to get out of this workshop. I know a few people already shared this, but it would be good for everyone to hear this, also for people who joined late. And I'm going to start with, I don't know, I'm going to make an arbitrary choice depending on who I see on my screen. David, would you like to go first?
No problem. First of all, thank you very much for putting this event on. I'm really looking forward to it. So I'm David Dixon. I suppose there's 2 parts of my life. One is I've got a day job, and the other one is that I'm involved in a couple of tech startups on the side too. So the day job is I work for an organisation that's within the Teesside University. It's called Digital City. We do 2 things. I help tech, digital and creative businesses grow. And in doing that, I've designed a couple of programs and taken them to market and delivered them. One is an investor readiness program. The other one is, I suppose, a scale-up program or a business growth program in old money. The other side of what I do is I help wider sectors take on digital, and ultimately that's digital transformation, which, let's be honest, means many different things to many different people. But it goes right from the bleeding edge of AI and blockchain right the way through to a basic piece of software sitting on a website, and it covers everything in between. That role is European funded, so the service I provide is free to the consumer. We've then got commercial aspect to it as well, where we can bring in some academics or some external delivery teams to enact some of the plans that we've put in place for them. On the other side of my life, I'm non-exec director, formerly non-exec director on a company called Booking Live based in Bristol. We collect a hell of a lot of data. So what we do is provide a booking solution, a back-end booking solution, mainly for activity-based organizations. But if you can think of any big corporate or local authority that basically rents out a person, a room, a something, then we provide the software in the background to enable that to happen. We provide that through an enterprise and a connect solution, which is basically a freemium solution. So we have a hell of a lot of data that we don't do anything with. So I'm looking, today is really, I'm attending to find out what I can do with that data.
Okay, great. That's a very solid use case. Who would like to go next?
I just wanted to say, David, I don't think I've ever seen the Tyneside Bridge look quite so attractive as it is in your background. But
that's not Tyneside. That's I'm nowhere near Tyneside. Wash your mouth out. I'm a Middlesbrough boy, so
no, yeah. I know. I heard you said Teesside, so it's like calling someone from Teesside a Geordie. I guess was not the right thing.
I don't associate with the Great Unwashed, unlike Mr. Nicholson.
So, Simon, would you like to go next, maybe?
Yeah, sure. Yeah, Simon Nicholson. So my company is Metascube. So we're basically business management consultants at the core of what we do. Obviously, we work in the digital domain. So we actually provide consultancy services through to Digital City that Dave's the member of through Teesside. And then we're also supporting, again, under contract, a program which is in Tyneside, Chris, as opposed to Teesside, but it's in Tyneside, Northumberland, which is Supply Chain Northeast. Again, they're both ERDF funded programs. But then there's additionally to that, there's a number of commercial companies that we work with whereby we provide commercial support to them. So whether it's business development or marketing, digital marketing, sales, and some of those companies obviously work in the AI space. Some of those companies work in the data integration space. So companies like Magic, I think you might be familiar with Magic Stylianos, possibly on Magic Software of Tel Aviv. And then also engineering companies that we deal with as well. So design companies, engineering, typically guys who are, or organizations who are actually manufacturing systems. So whether they be, I'll give a couple of examples. So whether they're control systems for nuclear subs, or whether they're passport printing systems for De La Rue, or whether they're subsea systems for Baker Hughes GE. They effectively do the design, or we do the design through to product phase of that. So there's an analog element to that, digital element, but a very strong software element to that as well. Mm-hmm. So that's effectively us.
Great. Thanks, Simon.
Thank you.
Hubert, nice to see you.
Nice to see you. Let me just, oops, there you go. Yeah, I am probably in the worst possible place to be in at the moment. I used to be in finance. I've been selling financial products to institutional investors all over Europe at various big investment banks. And in 2016, I finally did what I've always wanted to do, and I should have done much earlier, which is moving into hospitality. I really love it. I loved it. It is harder than you think, and that's what probably everybody tells you. But I still enjoyed it a lot. Unfortunately, Corona was a big hit for both of the businesses that I own and manage. One is a Southeast Asian takeaway chain in the city with, we had 7 restaurants before Corona hit. We were doing really well. I was working with LBS on a couple of data projects, and that's how I met Stelios the first time. And they've done a phenomenal service. The timing was just very unfortunate because a month before the project ended, we had to close down. And obviously the situation is completely different now. We're trying to restart the business now with a CVA. And there's quite a good chance that we might be back. And then obviously the outlook will be different, and we're going to look more into data-driven delivery businesses as well. The other business I own and manage is a small Austrian restaurant in Italy, where same thing, we did really, really well. I took it over 2 years ago. Corona hit, we were closed. I thought we were dead, but we somehow managed to bounce back much faster than I ever hoped for. We started an online business last summer, which from 0 to £30,000 a month in 4 months, which was completely overwhelming and absolutely incredible. Again, we're nowhere in terms of data, in terms of usage of data, and in terms of usage of any kind of digital appliances. And it will be very interesting with that as well, because here the restaurant will stay, and it will continue to, we will continue to work from here. But the online business has a huge potential, and I'm just starting to build up a digital infrastructure behind it. because we sell all over the UK and we get orders from all over the UK. And I think we're up to something really, really incredibly potential here. Any kind of AI, any kind of data science will make a massive difference for us here.
Yeah, it was quite sad to hear what happened, you know, how COVID affected you, but I guess, unfortunately, you're not alone in this. But I remember last year, in the work we did with London Business School, there were some issues with the data, but it was a very good data set. And I mean, there are like so many things you can do in this industry, right? From
absolutely, and I mean, mostly with stuff like how we work with fast-paced, quick service restaurants. We had a weekly changing menu where we cooked different dishes and they rotated. And there was so much information hidden behind the data we had. And even scratching on the surface together with the guys that worked on the project was extremely interesting. And I mean, it's not a secret anymore. And I guess even the most doubtful people by now have understood that data really is the new gold and the new currency. And it doesn't have to be that you abuse customer data and like Facebook or other big conglomerates just sell it and make a living off of it. But you can become a much better business by using data, because optimizing our menu, optimizing our staffing, optimizing our production, that is just a very clever and very positive and constructive use of data. And I totally want to do more of it. It is always a bit of a challenge for small businesses. And that's why I was so amazed and so happy about the LBS project, at the same time sad that we couldn't go through with it, because having a group of highly skilled, highly motivated, well-trained people working on a small business with like 3-4 million pounds turnover is absolutely incredible and unaffordable for a business like us. So I would be very much interested in data solution or AI solutions that can be scaled to a point where even small businesses have access to it and can use it. And that would be very interesting.
Great. Yeah, absolutely. And for those of you who don't know, I'm also a data science advisor at London Business School, and Hubert participated with his company last year in a program that has students work on company projects. And it's a very, very successful program running once per year. So if anyone's interested in this, now registrations are closed, but it's going to run again next year. Feel free to ping me about this. So next one, Janet. Hi.
Hi, everyone. So I'm Janet. I am working for a company called Zomedica. We're a medical device product development company. I am director of technical innovation, and then we added out advanced analytics. So my purpose really, and that's why I signed up for this class, is I want to build a department at Zomedica because, as you know, medical devices, now everything is around data. We want to start going that way. Want to make sure we deliver good product to our clients. And the only way to do that at this age and time is to do data science with medical devices, especially with all the variables around. So I'm trying to build out the strategy for my company on how we're going to do that, what people should we hire, what expertise do we need in the building or maybe outside the building as consultants, in order for us to be productive for our clients, and making sure that, as you know, consulting companies, we have roller coasters. Sometimes we're very busy, sometimes we're not, to make sure that we also have the right team in place that is always busy. I've been working with this company for the past 8 years. Prior to that, I been getting my graduate degree in mechanical engineering. So not data science person, but use a lot of statistics throughout my career, because that's, again, something that you have to face as you work with data. And yeah, that's it.
Perfect. And I think you're joining from the US, right?
Yes, I'm calling in from the US, and I'm actually on maternity leave. So I have the baby sleeping over here.
Oh, well, thanks for making it. Yeah, you told me about this. I hope I'm not going to wake up the baby.
No, I want her to get used to this.
Yeah, it's good to get a head start, right?
Yeah.
Maybe we're going to run another program, Data Science and AI for babies and toddlers. Give them some head start in school. So great. Okay, I think that's another very good use case. And who's next? Krishika, I know we spoke before the event started, but maybe you'd like to share a few things with the rest of the participants.
Hi, everyone. So I actually work as part of an asset management firm based out of London. And most of our verticals are now, finance. We're moving more away from the traditional and to the tech-based finance industry. So some of our verticals are tech and AI-enabled wealth management platforms and neobanks and life assurance platforms. So that's exactly how I've come into this course, just to see and understand how AI and deep learning works into the finance industry and its various use cases on just wealth management and finance management.
Great. So you're not. Would you say you're in fintech, or?
We're more of an incubator for fintechs.
Yeah.
As an asset management firm, we have our own verticals, and then we incubate them into these companies, and then it's carried on by the team then that gets elected to it.
Great. Who's next? Brandon. Well, we know each other, but feel free to introduce yourself.
Hi, Stelios. I don't know if you can see me.
Yep.
Right, cool. Be short and sweet. I'm at Stelios. My company's 7gen Analytics has been working with local government to work out how we can use data to accelerate delivery of homes and housing, sustainable communities. Unfortunately, the data is horrendous. So what we've been focused on is how we capture, validate, and visualize better data and then eventually use artificial intelligence in the future. Full stop.
Great, thanks. So it's clear that there are people from many different industries and sectors in this group. And Paul, I know you gave us a very extensive introduction about yourself earlier, but maybe you'd like to give like a 1-minute intro for those who weren't here earlier.
Yeah, sure. My name is Paul Benedek. I own a consultancy that specializes in cybersecurity and compliance. Now, started out many, many years ago in security and worked across financials, medical, and identity. Moving through time, I built the consultancy to look at specific challenges around technologies. And recently I found myself moving into artificial intelligence from a consultancy, solving problems, how to deal with data, how to secure data, and how to meet compliance standards. So we've got the GDPR, we've got the Medical Devices Directive, we've got HIPAA. I have clients who've got all of these challenges that they need to meet compliance concerns, and also they're utilizing technologies such as artificial intelligence and machine learning. So recently, what I've been doing is not only providing consultancy services, but audit services. And I specialize in cloud as well as cybersecurity. So my experience in cloud, looking at AI platforms, everything from the way that they're built at an infrastructure level, to the database level, to the performance level. I've worked with organizations where I've been called in to do an audit to make sure that things are compliant, or alternatively where there's been a buyer who's interested in the technology and they want to do a merger and acquisition. So my skills and interest in AI are basically to look at AI as a unified ecosystem and to understand that ecosystem and to be able to audit, but also provide advisory services on that. And as suggested, I've got medical clients. So I've got one client who's providing artificial intelligence for stroke care. I've got another one who's looking at it for heart attacks and being able to look at blood flow to be able to predict the probability of a heart attack. And I've got biometric companies who are looking at identity and other services. So from a compliance perspective, very much at the high end, regulated markets, and understanding what goes on in those regulated markets, advising them, but also taking lessons from those markets and applying them elsewhere. So the lady in the medical sector, I'm taking medical information and providing that to financial companies because the use cases are very similar, and conversely taking information from financials and using that in medical across AI and across platforms.
Great, thanks. So I guess we'll get started, right? So does everyone see my screen? Overview, demystification. I assume that's a yes. So so now it's like 5. I guess we're going to run this, the part of the next session, and then we can go on a short break. If anyone has a question, you can raise your hand, which I guess is how people do things in Zoom. There must be a hand somewhere in the chat. And obviously, again, because we're online, I can't really get direct feedback, but so I'll try to organize the sessions with breaks in between, etc. But if someone has a suggestion, then feel free like to write it in the chat. And yes, this is also being recorded. And so if someone needs to take a break while we're still going on, then that's fine. And I guess, yeah, we can get started. So this first session is a very introductory session about the history of AI and data science. And it's more for those who do not really know much about the topic or have not worked much in this area. And I essentially created this session because I wanted to demystify lots of the jargon and the terms that are being used and quite often abused, like AI and machine learning, what's the difference between them. And something which I like to do when I start the workshop is always ask the audience what they think data science is, right? So what is data science? And would actually someone like to answer this question? I'm just curious to see what's the definition of data science you might have in your head, according to your opinion.
I would say any kind of constructive and progressive use of data and information of data for and the elaboration, any kind of elaboration of data.
Mm-hmm. Elaboration of data. Okay, that I think it must be the first one that I've heard using this kind of definition, but you know, it's not too far off, right? Chris, you seem to be thinking about something. No, we can't hear you. We still can't hear you. Okay, there you go.
I'm still offended that you didn't ask me to introduce myself, but I'll do it after the break. You're just probably pleased that I was quiet for a few minutes. But I think, not necessarily a definition, but data is leading to insight and decisions, and the science piece of it, to me, means that it's as a kind of engineering or discipline, so that it starts to become outcome based.
Mm-hmm. I mean, all of these definitions are correct, right? And I think if I was going to ask like 20 people, then they would have 20 different definitions. And that's why the definition I give here is that data science is simply about using data to do useful stuff, which is a very broad definition. But the humans, like mankind, has been using data for a long time, for around 200-300 years. Like statistics have been around for the last 200 years or so, but we've been using data for much longer than that. And there's also a history of close to 100 years of trying to replicate human intelligence inside the machine. And data science is really a term which has brought together many, many different disciplines, which were kind of related to each other. But before the term data science came about, and let's say before modern telecommunications, because many of these disciplines had been going on for a long time before the internet, there were many activities taking place disjointly, right? And there was no coherent framework to integrate all these disciplines. And that's one of my favorite graphs of all time, which shows how the different disciplines that comprise data science are related to each other. So for example, machine learning is a subset of AI, and they are both tangent to statistics. The reason they're tangent is because they try to answer very similar problems, but they take very different perspectives, right? And then we have some other terms like data mining, which used to be very popular. It's not that popular anymore, which intersects with machine learning and AI. It intersects with databases, it intersects with KDD, which means knowledge discovery in databases. And you can see that somehow all these things are related to each other. And these disciplines have been around for a long time. And data science really is a term that has brought everything together. So you don't really hear someone saying, oh, I'm a data miner anymore or anything like this. They'll say I'm a data scientist. And then you see this circle around the center. And the circle essentially, what it just demonstrates is that data science is an applied affair, right? So it's not so much a scientific discipline, but it's more of an umbrella term that brings all these disciplines together. And some of the most important skills are around the application, around what I call the soft skills of data science, right? Like business strategy, domain knowledge, presentation, because it's really not so much a scientific discipline, but a term that was created to bring together pre-existing scientific disciplines, and the goal is business impact, yeah? So in this first session, we're gonna go through a brief historical overview of the history of data science. And I'm going to talk about the three core fields, because I believe there are three main fields which have shaped the history of data science the most: AI, machine learning, and statistics. I will explain the difference between all these. This is something which is important to remember for the hiring part as well, which we're going to cover either later today or the next session if we overrun on time, because someone's training is really going to play a large role in their skills and how they approach certain problems. And then there are a few different subfields like cybernetics, computational intelligence, which we will briefly touch upon in order to understand how they've all come together. So I'm going to start with AI, and artificial intelligence is a discipline it's a bit of a rare case that it's a scientific discipline for which you can pinpoint the exact point in time when it was created. So it was created in 1956 in the US. And the original vision back then was to recreate human intelligence in some way. And back then it was very closely integrated with cognitive science, right? So if you know, like, I guess some people in this audience must know Noam Chomsky, for example, the very famous linguist. So there was like a whole bunch of researchers that were into this area of cognitive science. So Noam Chomsky was like in linguistics, other people were cognitive science. These guys like Herbert Simon and Minsky were in AI, but also a bit of psychology. It was a very exciting time, and there was lots of optimism, and they had a vision as to how to create a thinking machine. And they believed that the way to create a thinking machine back then was to use what they called logical reasoning or a rules-based or symbolic approach. And this approach essentially consisting of creating a very large number of rules and then having algorithms which can make inference based on those rules. So for example, one of the early wins was something called the Maysin system, created by Stanford in the 70s, contained 600 rules about diagnosis. And at that point in time, they claimed it was better than junior doctors, which is a bit funny because now companies like Babylon Health or other companies in medtech, they're trying to do the same thing. So I'm not sure how well it performed back then. I know systems now perform better, but then again, people now are more aware of some of the challenges of using AI for diagnosis. And it works in a pretty primitive way compared to modern standards, right? So there was nothing as like machine learning or data being used. It was essentially a bunch of if-then rules and an engine to interpret those rules. It was never deployed because of ethical concerns. And then classic AI also dealt with some other topics like automated planning and scheduling. So they dealt a lot with toy problems, like the traveling salesman problem, the missionaries and cannibals problem. For those of you who don't know this problem, the traveling salesman, essentially the question is, how can you find a path through each one of the cities? In this case, I think these are all the capitals in the United States, or at least some of them. How can you find the path, which is the minimum distance path, but without going through the same city twice, right? And this sounds a bit like a toy problem, but this type of algorithms are applied a lot in optimization and routing and supply chains. So Hubert, for example, you know, if I'm not sure how your you know, how you're connecting with your producers, what their supply chains look like, but it's not unlikely that some of them will be using some algorithm like this in order to solve routing problems. So these are like really commoditized. I don't even think that there are many products which would advertise this as AI these days. And AI was going well up to a point, and probably they overshot a bit, and eventually they things came to what is now called AI winters, right? So the AI winters there are two AI winters, and these were pretty much like the dot-com bubble, but for AI. Essentially, the community of AI overpromised and under-delivered, and they believed that they would have cracked the problem within a generation, and actually the systems weren't really ready to be used in a commercial setting. There was lots of money that was invested in AI and nothing came out of it. And then AI ended up having a very bad name. In the second AI winter, there was the resurgence of the expert systems being those systems like Mycin that work based on rules. But again, the market exploded more than it should have, and eventually it crashed. And Wikipedia actually has a great breakdown of the AI winters. If anyone is interested to know more about the history of bubbles, this is like everyone knows about the dot-com bubble. No one knows about the AI winters bubble. If you want my opinion, I don't think we're going to go through another AI winter anytime soon, because I think now there are way more solid use cases for AI, and it's actually being adopted by actually all industries. I'm not sure if I can say this about all technology companies like Tesla. Obviously, you know, that's each one has their own opinion on that. So, but regarding AI, I would be surprised if we go through another such event. And eventually, the classic approach to AI, and this started in '56. This is when the term was created, and it ended up in a pretty, let's say, not nice way. It wasn't a very glorious end. They didn't really create working robots or anything like this, but they ended up with a few interesting algorithms, some scientific contributions on topics like scheduling or cognitive science, and that was just it, right? So this was around the 80s, and now we're in the 80s and there's no funding, right? So AI has become a toxic word and no one wants to hear anything about it. And then there's another term which starts to become more and more popular. And this term is machine learning. Okay, so machine learning starts getting popularity around mid-80s, 90s, and people stop using the word AI and they're using the word machine learning. So before I go and explain the difference, I'm really curious, does anyone in the audience know the difference? I guess the silence is a clear no. And yeah, the reason I'm asking this is because I think these terms are really being used and abused a lot. And the thing with machine learning and what we call AI is that now many companies, especially startups, they like to say they're using AI. Okay, and the problem is that AI sounds probably cooler than machine learning in many aspects, but they're like different things. So AI, when we're saying AI, we're essentially referring to either classic AI, what I just described, or we are referring to the grand vision of recreating intelligence. Whereas machine learning, if you go back to the graph I showed you, sorry, let me go back. You go back to machine learning is a subset of AI, right? So why is it a subset of AI? Because it is a particular approach to using artificial intelligence. Okay, so machine learning is a data-driven approach to creating AI, and it's called bottom-up approach in contrast to top-driven, because in contrast to the classic AI systems that were based in rules. So this is just based on data. And the idea was around through the late 50s that machine learning is about giving computers the ability to learn without being explicitly programmed. But it took off, actually took off around the turn of the millennium. So in the 90s, it started getting more popular because AI became a toxic word and researchers were trying to stay away from it and come up with a different way to go about it. But then around the turn of the millennium, this really exploded, this approach. And the reason it's exploded, it's pretty easy to understand. So whereas the previous approach was very difficult to use, it required the knowledge of human experts and lots of manual inputs for people to come up with rules, the machine learning approach is simply based on data. So machine learning is based on using algorithms that can learn on their own. And what an analogy I like to use is that I like to see machine learning as the next evolution of computer science, because computer science deals with the automation of information processing through algorithms. Machine learning deals with the automation of the creation of algorithms. So to give you an example of what this means in practice is, let's go back to autonomous vehicles. I mentioned Tesla earlier, which is one of the companies working in this area, right? And they're like, two different approaches to how you can build an autonomous vehicle, right? So there's the classical engineering approach, which is take an autonomous vehicle and break down all the problems that an autonomous vehicle needs to solve, right? So it needs to stay on the road, it needs to be able to stay on the lane and to figure out whether there are any pedestrians around it, etc. Right? So this is, and then you're like, you know what? I'll create an algorithm for each one of those instances. So this is a more of a classic engineering approach, more of a computer science approach. Then again, there's another approach. I can't remember which company is using this, unfortunately, but I had watched an interview with our CEO recently. And the pure machine learning approach is, look, we're just going to use a deep neural network and it's going to learn how to do all of these things at the same time, right? And this approach is obviously more exciting, right? It's more exciting because you can, it's more efficient, right? So once you have enough data, then you just have an algorithm, it can learn everything on its own. And obviously that's a very powerful concept. And another thing that's very interesting around AI, and that's more of a scientific reason, sorry, about machine learning, is that machine learning algorithms are built in a way that they can deal with uncertainty, right? So there are many domains like finance, I guess is the prime example, where uncertainty is inherent in the domain. So no one can make perfect predictions about, you know, the stock market, insurance, or whatever. And machine learning algorithms are very good in dealing with this kind of uncertainty and extracting little bits of information from data, okay, in order to handle this type of uncertainty. Then again, machine learning is not perfect. Machine learning can't handle logic rules directly. It's not very transparent, okay, which means there's huge issues around bias and accountability in machine learning, which currently researchers are trying to address. And also machine learning is not very good in using domain knowledge, right? So whereas the classic AI approach was only about domain knowledge, then machine learning is kind of, you can use domain knowledge in machine learning, but it's a bit challenging, right? So we're not there yet. And obviously around algorithmic accountability and transparency, this is something that is actively being researched, and I think it's becoming a more and more important topic. And something I'd like to ask you, would anyone be interested in an event around this? Because we were thinking maybe to run some kind of free webinar in the next couple of months on this topic, like AI, transparency, interpretability, algorithmic bias.
Yeah, I'd be very interested in that.
Yeah, I would agree with that, especially for medical devices. That's a big issue with AI being black box.
Okay, good to hear. Perfect. Yeah, so we should run this. I mean, the challenge, I was looking into creating some content for this, but the challenge I'm facing is that right now it's a very technical topic. So I want to balance things. I don't want to just run a webinar and, you know, just talk about some algorithms for 2 hours, you know. But yeah, I think I'm going to spend some time doing research, and maybe we can do a quick overview and go into more technical details for those who are interested. And there's like lots of research being done for structured data, but also for computer vision. For computer vision, I guess we have some really cool algorithms, but they're not that easy to understand. But for other, like if we're talking about structured data, let's say you want to predict, you have an algorithm which you're using to make hiring decisions, right? You want to make sure this algorithm is not really making decisions because of someone's ethnicity or gender, right? So we do now have methods which can say, hey, this algorithm made this decision about this candidate because of this candidate's gender, for example, right? So you can see this, you can audit the algorithm and you can act accordingly, which is pretty good, right? I'm gonna skip over the slide for those of you who wanna deal into the more technical details. I'm gonna give you the slides later anyway. These are just the names of some algorithms. And I'm gonna move on to deep learning. I have quite a few slides here, but I'm just gonna skim over them. It's just, I thought it's probably worth if I mention deep learning because it's deep learning is a branch of machine learning, which has become so popular that it has revolutionized the space. And these days, many companies that are using deep learning, they're saying they're using AI, partly because AI sounds cooler, as I said, and this can help them raise more money, but also partly because there are genuinely some people who believe that deep learning can lead to real AI. And deep learning, essentially, it started, the technology was there since the 80s, okay? It just took a very long time for this to take off. We needed more data, we needed better computers. And then what happened is around like 10 years ago, you can see on this graph that by using deep learning, the performance on a speech recognition task was dramatically better the more data you gave it compared to previous techniques. And then we observed similar things in computer vision as well. And then people like lost their minds. They're like, well, that's amazing. It was really a revolutionary technology. Suddenly everything worked better. With natural language processing as well, we had, this is classical natural language processing, where you can see that there are many, many different steps. And with deep learning, you remove all the steps and you replace them with a deep neural network. Which essentially made the process much faster and easier. So now Google, for example, is doing heavy work on translators, and they build these networks which can translate from 100 languages to 100 different languages, right, in one go, which is pretty impressive. Computer vision, now this has been commoditized to a huge extent, like anything relating to object recognition, like other smart applications like coloring, is now the domain of deep learning. And something which I'm also personally involved in, I'm actually going to send you the details for anyone who's interested, where is it? Sorry, I just need to escape. Oops, sorry. I was going to talk about generative AI, right? Because I'm not sure how many of you are familiar with generative adversarial networks, but it's a revolutionary technology which allows us to create realistic images, realistic text, realistic sounds with insane levels of, I wouldn't say accuracy, of realism. And I'm also personally organizing a meetup in this area. We had a very interesting event yesterday. Next month we'll also be running something which will also probably touch upon the space of NFTs. So if anyone's interested, I'm sharing this now. And let me share also, sorry. Let me also share a recording of the previous event, just for anyone who's interested in this technology. And I'm also not sure if you've also seen our main page. If you see our main page, then you're going to see a video there, which has been generated by AI. So there is a human there speaking about what the company is doing, the Tesseract Academy, but the human is authentically generated. Okay, so where
is this in effect deep fakes then? So where it looks like it's the real person saying something, but actually it's just a computer.
Yeah, so essentially what they've done is they've taken an actor, then using GANs in order to generate like speech and etc. and the expressions. But we're not far from actually this kind of technology being used for, I think, all stunt doubles in movies, right? It's progressing very, very fast. The main roadblock is just the processing power required. But we're just getting there, right? Getting there. So it's a technology I'm very interested in. If anyone wants to know more about this, let me know. And I have also text generation. This is an old example. Now text generation is much more powerful, but this was actually the first popular example of text generation with deep learning, which I still think it's very, very impressive. It was a deep neural network that it was trained on the works of Shakespeare, and it had learned to speak like Shakespeare. More like, no, I don't think that Shakespeare was speaking of it in this way, but I'm like his plays is what I wanted to say. And it was, back then, networks were pretty good in creating dialogue, which seemed to be realistic, but it really didn't have any plot or anything. These days, we can actually create whole synthetic text. So there's this, so let me find this link. And there's a link, I'm gonna share it with you, that's called Talk with a Transformer. Talk to a Transformer. And which you can see here, right? So it's pretty funny if you want to check it out. You can say like Elon Musk's debut album. You give it the sentence, and then it starts talking about, you know, as if Elon Musk is a musician and what this album is going to be like, right? So essentially, where I see deep learning heading towards to is, I think deep learning is not the de facto solution for anything relating to computer vision and language. We're seeing many applications in the medical domain, and I think that the next frontier is generative networks. The challenge now is the processing power required to run these networks, but it's going to get more and more efficient, and processing power is going to get cheaper and cheaper. And I think we're going to see a revolution in the creative industries, or industries like marketing, that are connected to the creative industries in a way. So we might see, for example, deep learning writing copy for websites. Actually, there are quite a few products out there, but I can't comment on the accuracy as to how well they write copy, or for ads, or music for ads, all these kind of things. But it's clear we're heading in this direction. Any questions so far, by the way? Okay, if there are no questions, then we can move on. So I covered briefly AI, classic AI, machine learning, and now I'm going to briefly talk about statistics. And statistics is the third cornerstone of data science. It's the oldest discipline. It was created in the 18th century. But unfortunately, even though it was created 200 years ago, it's not as popular or as sexy, let's say, as data science, as AI and machine learning. Yes, this is more of a matter of branding, I don't know. And there's, if you remember from the previous picture, where is it? Here. So you see that statistics is tangent to machine learning and AI. The reason being that statistics tries to solve the same problems, but it takes a different perspective. Yeah. Let me see. So statistics is different compared to machine learning, partly because of its history. So statistical science deals with smaller samples, and it cares more about interpretability. So the challenge that machine learning has around bias and this sort of things with statistics is basically non-existent, right? Whereas machine learning is more focused on predictive power and experimentation. For those of you who don't know who this guy is Ronald Fisher. If anyone walks around Hampstead Heath, you can find his old house. There's a sign outside. He was one of the fathers of modern statistics. And as I was explaining, essentially the differences in the two disciplines are mostly due to their history. And historical curiosity aside, this is very, very important when hiring, because statisticians have a very different approach to data science compared to machine learning people who are usually trained in computer science departments. Yeah, and we'll cover more about this in the session in hiring. My opinion is that these kind of comparisons are good to know about the different approaches to the same topic, right? So data science deals with the extraction of value from data, but it's good to know about the different types of thinking about the problem. That being said, I think these are all just tools in one's toolbox, right? So I'm happy enough to consider myself both a data scientist and a statistician. And then, as I mentioned, there were a few other subfields in the process relating to which either try to recreate intelligence inside the machine, or they try to analyze data like cybernetics, artificial neural networks, machine learning, data mining, machine learning, we covered it, pattern recognition. And you have to understand that before the internet, there were different schools of thought at different universities or companies sometimes. And what this meant was that there were people working on the same problems independently, right? And if you Google artificial intelligence on Google Images, you see all kinds of definitions, like people saying that artificial intelligence relates to data mining or reverse engineering the brain, or other people saying that they relate to expert systems or fuzzy logic. So you see all kinds of things. And then you have some definitions, I don't really want you to read all this, but if you go into the definition of computational intelligence, you see many different buzzwords, like neural networks and fuzzy systems. And it's the same with definition of KDD, knowledge discovery in databases. So what I'm trying to convey is that this whole issue that exists now in technology with buzzwords, it has been going for quite some time, right? So I explained the difference in AI and machine learning, and now I could go on and explain the difference between pattern recognition and machine learning, which probably wouldn't really help anyone. Essentially, the term data science, as I mentioned, was created as an umbrella term in order to bring all these things together. Okay? And it was largely created by companies, like big consultancies, tech companies, in order to sell, actually, because it's easier to say I'm a data scientist than saying, oh, I'm just, data mining or I'm dealing with cybernetics. And it took some time for academia to catch up and actually started creating programs in data science. And there was some early confusion around terms like big data, what's the difference between a data engineer and data scientist. Another thing, 99% of the people agree that the data scientist deals with analyzing data, whereas a data engineer deals with more with data infrastructure. Big data, I mean, it's not a popular term anymore, I guess, because data is already big and getting bigger, and many of the technologies that this term was used in order to sell, like NoSQL, now they're everywhere, right? And we're seeing many other, so even solutions which would have been considered exotic, like graph databases 10 years ago, now are breaking into the mainstream. And we're going to cover the session for hiring that data scientists usually fall into one of three types. So either someone who studied, either a statistician who were, let's say, data scientists before data science became cool, computer science people who studied machine learning. This is a very specific type of person. And then people who have studied something else and then they've converted to data science, which we see this happening again and again these days, right? There are many, many boot camps. I also ran a boot camp for those who want to convert to data science from some other career. And essentially these, if we take, like I mentioned, there are three core fields in data science, like AI, statistics, machine learning. I'd say that most of data science now is dominated by machine learning and then a bit of statistics, right? So it's 70% machine learning and 30% statistics. I'm not gonna stay too long with this slide. This is more for summary slides. Again, I'm gonna share the deck with you as well as the recording of the video. And something important, these are some takeaways from, this is some things I've learned throughout my career, is that their life moves in circles and trends come and go. And what you're seeing in technology, whether we're talking about investing in technology or coming up with new solutions, is that things come and go all the time. So there are, for example, unfashionable techniques like fuzzy logic, which not many people know about it, which are still around. They're still being used, even in important systems like trains. I'm not sure if the tube is using fuzzy logic, but I think some metro systems are still using fuzzy logic. So it's not popular, but it's working. Techniques from different fields in machine learning, sometimes they jump around in other fields of mathematics, etc. And we see them resurfacing sometimes with different names. And big conferences still exist for some of the like fields I mentioned before, like data mining, which can be even more confusing for someone entering the space. And also we see techniques becoming popular and unpopular and popular again. So genetic algorithms were all the hype in the 90s. Then probably you've not heard about any companies specializing in genetic algorithms now, but Uber started investing heavily in this technology again, as well as Google, right? So something which the Silicon Valley guys are very good at doing is taking ideas which have been around for 20 years and then rebranding them and presenting them as something pretty novel. I guess that's for those of you who are looking into either investment or working with some of these technologies. Because many times people ask me, oh, you know, I've heard about this new thing and that new thing. And quite often this is just a rebranding of the same thing again and again, right? Deep learning is also essentially rebranding to some extent, because the technology is revolutionary, but the basics of this technology have been around since the 80s. So yeah, these are the key takeaways. Thing I need to repeat this, and yeah, that was the first session. Any questions? Anyone? Okay. So if everything is clear, then we can move on. Let me share the next slide. I hope no one is confused. If anyone is confused, please raise your hand, because the purpose of this session was to demystify AI and machine learning. Okay.
No, I'm all good, thank you.
Cool. So yeah, this is more of an introductory session. So I'm just trying to share my screen to share the second deck of slides, which is where now we're getting into the more interesting part, and we're going to deal with data management, and we're also going to start working on some exercises. All right. So let me. Why is it not showing this? So I think I have to share again. Share screen, data management. Okay, data management. Okay, so data management. So in this session, we're going to cover data management from a decision maker's perspective, and that's a very important session because we're going to talk about some pretty common sense topics, right? But while many of the things I'm going to say are like data science common sense, they are, I see these mistakes happen again and again, right? And this is simply because these topics are very tricky to deal with, okay? These topics are very tricky to deal with. So I'm going to first talk where data comes from.
ويستخدم الوسائط وجها لوجه والكترونيه وورقيه مع تعبير الوجه.
Sorry. Okay, I think someone might be speaking on the phone. I'm going to start with data sources and data collection methods. Okay, that's just something I wanted to get out of the way. So there are like different sources of data. These days, from like published sources to experiments, which is my favorite because it's the most controlled source, databases with surveys, observations or automated data collected through observations like from maps, etc., passive measurement. And there are like two main types of data collection, observational and experimental. In most cases in business, we're dealing with observational data, right? Which means that we don't have any control over the variable of interest. We just take data as it is. And then we have experimental data, which we encounter more often in science and in the medical domain, such as when we have A/B testing. So this is just some definitions I wanted to get out of the way. And now we're moving on to something very interesting and our first exercise, okay? So as you know, I'm a very big fan of frameworks and tools, like simple frameworks and tools for those who want to work with data. And there are, and one of my favorite checklists is a checklist for what that I call the data acquisition considerations. And there are like four key points on this checklist, right? So the appropriateness of the data, the nature of the data, the time requirement of the data, and the cost of acquisition of the data, okay? So this is a list that anyone should go through when dealing with data collection and when they want to use data science once they have collected a significant amount of data. So let me explain each one of those points in turn before we move on to our exercise. Okay, so the first point is the appropriateness of the data, and this is self-evident, but then again, it's self-evident when you hear about it. It's not always self-evident when you work with data. And the point is that garbage in, garbage out, right? So if the data is rubbish, then there's nothing you can do about it, right? You don't have the right variables, then there's no way to save the day. And it's very often that some company, they've collected data and then you wanted to use it for a specific purpose and you realize that some variables are missing, and I'm going to cover this. I'm going to cover one such case study later on. Then the nature of the data. So what this refers to, is that in some domains data collection can be noisy or biased, right? So for example, maybe you're dealing in a domain where data is protected and you don't have access to personal identifiers, right? Or maybe you're dealing in a domain, like I've worked with radar data, and in radar, there's lots of noise, right? So the data is noisy and there's nothing you can do about it. And you have to learn the way to deal with this. Or maybe now I'm working on a project with financial data on private equity, and we're working with two databases in order to cross-reference reports from private equity funds, right? Because in some cases there's a difference. So all of these refers to the nature of the data. In some domains, there are certain types of errors or noise, and you need to be aware of this and find a way to solve it. Then the time requirement. How long does it take you to collect data, right? Let's say that you're in a real-time domain. I've worked in sports in the past, and getting data real-time data on actions, it's challenging, right? It's more challenging than getting, for example, data after a game. So depending on what you want to do, you have to be very careful. And this also relates to data engineering, right? So if you're dealing with huge volumes of data, it is much easier if you just want to store everything in a data warehouse as compared to if you need to run with online transactions, right? And then the cost of acquisition, okay, which is very important, mostly for startups. You get sources, for example, I'm working on I'm consulting for a fintech company, and the cost of some data for private equity is, I think, between $20,000 to $30,000. So if you want to get the Twitter data, because I've worked with Twitter data in the past, then the cost is around, I think it was 10 to 12,000 pounds on a monthly basis. This was access to historical Twitter data. I'm not talking about crawling Twitter. So obviously, all these points are very, very important. So any questions about these points before I move on to the exercise? Okay, so if everything is clear, I'm going to move on. So now we're moving on to our first exercise. And what I want you to do is I want you to think about, okay, so this is a scenario for those of you who do not face a data-related challenge, right? So if those of you who face a data-related challenge, okay, like you have a specific problem in mind or you're working on a new business idea, I'd like you to start thinking about these checkpoints, and ideally I'd like us to discuss them now, and how these relate to your particular challenge or to your business, right? For those of you who don't have such a challenge, or they're not working on an idea, I'm just going to present to you an example from my own experience. I've worked on this problem in the past, and I was back then working on a sports betting company. So the goal was to create predictive models to predict sports outcomes. And we wanted to get data, right? And we asked the vendor to give us some predefined packages with data. And then we encountered a few different challenges, okay, around the predefined packages that the vendor gave us. Okay, so I'm talking about one vendor only, right? And we we faced a few different dilemmas. And regarding the appropriateness of the data, we had no idea at that time whether the data was appropriate for prediction, right? Whether they would allow us the data that the vendor provided us in those packages, whether this data was good enough for predicting outcomes. Then the nature of the data, we knew that sometimes the data contained mistakes and we weren't sure how to deal with them. Then the time requirement, the vendor told us that they couldn't give us real-time data, which we wanted to have in order to get an edge. It would give us data with a 10-minute lag, and the 10-minute lagged data were 5 times more costly than the data that we would receive after the game. Okay, so the initial idea was to predict outcomes real time during football game and place bets and make some money by capitalizing on machine learning. And then we were faced with all of these challenges. So what I'd like to ask you to do is maybe spend the next like 5 minutes or so, or 10 minutes in order to come up with this checklist for your own particular challenge or or problem that you're trying to solve. If you don't want to, if you don't have something in mind, then feel free to think a bit about this challenge I'm presenting to you now, which I had actually faced something very similar in the past, so we can discuss about it. Any questions? Anyone? Okay, does everyone, wait, is someone writing in the chat? All good. Okay, cool. So then I guess we can take like a 10-minute break or so. And I guess you can start like working on this. Again, the purpose of the workshop is that as we go along through the different sessions, and you're slowly going to start working on, then you're slowly going to start coming up with a plan, right, as to how to approach a certain problem. And actually, let me share this with you. Sorry. What is, instead of, I guess, okay, something which you might want to do, it might help you as we are, help you as we are. Let me find it. I'm not sure, I think I failed to share the data strategy canvas, which is something which will help you come up with the right plan for your particular problem or challenge that you're trying to solve. So I'm gonna share this now. So canvas, okay, so it's here. You can find this here, okay? So you can find the document which as we go through the sessions, you can simply work with the table that you see on this document. So you'll see those 4 points in the checklist with it just outlined, and then there are going to be a few other points, okay? So actually, let me share this. So, okay, let's do this, and then we'll continue like 5-10 minutes, yeah? Okay, how's everyone getting along? Any progress? Anyone who would like to share what they've done? So if you need more time to work on this, we can wait, or if you want, you can share it with me later. I hope you all have access to the document I shared, the data strategy canvas, where if I just share the canvas for a bit, share with you. As you can see, there's a very nice table here, and these are all the points that someone needs to fill out in order to get started with data strategy, right? And I mentioned about the appropriateness, the nature, the time, the cost, and these are some of the 4 key considerations for data that we just discussed, okay? And then we're going to move on and fill out some of the other topics like who you should hire, culture, etc., etc. So let me share the okay. So if no one wants to share anything, basically if anyone wants to share anything, maybe you'd like to write in the chat room. Otherwise, I guess we can continue. Oops.
Okay, from my perspective,
yeah,
I found it difficult to pinpoint the why, or the what should I say. Now, in terms of collecting, ultimately, if you're a sports betting company, or say you just want to actually, as an individual, I want to know whether my team is going to win this game or not. Now, at the very beginning, there's always going to be infinite variables, but at the very beginning, you don't know how the match is playing out, whether there's 90% possession in our favor or the other team's favor, whether that possession is in the right areas rather than in the defensive areas. So I guess as the game goes on, you're going to reduce the risk if you're predicting based on what's actually happened rather than at minute 0, whereby it literally is infinite. But before that point, you could use historical data to highlight statistically home versus away, who wins. And then you look at that team in particular, how many away games have they won in the last 6 months, in the last 6 years, in the last 60 years. So in effect, you can use history as a great indicator to have an outline of where we think it might go. But actually in that moment, there's so many different circumstances. There could be a red card come along that you can't forecast. There could be an injury come along that you can't forecast.
Yeah.
But I just think it's supremely difficult, and I couldn't get my head around with so many variables how.
Yeah, I mean, look, the purpose of this exercise is not to try and solve the problem. It's both to some extent. The purpose of this exercise is to appreciate how all these different points outlined, how they interact with each other, and what would you do in each one of the cases, right? That's why if you notice that for each one of the points, there is one dilemma, right? So we have some variables, but maybe they're not the right ones for prediction. We have data, but maybe they contain mistakes. What are you going to do about it? You have data from a fast resolution, but you're not sure whether these are the right variables, and they're 5 times more costly than after game. But if you go with after game data, then what are you going to do about the real-time predictions that you wanted to do, right? And when I run this exercise, I've heard all kinds of answers. from I'll change my business model completely, maybe you should do something else, just predict the game, predict the outcome of a complete game instead of real-time predictions, down to I'll go to other vendors, I'll try to crawl data, I'll try to fix the noisy mistakes by cross-referencing different data sources, and all these are viable solutions, right? So in reality, it's rarely a straight line. In real life, you're probably going to have to deal with situations much like this, right? Where there are many, many imperfections. And again, this is a clear use case, like we want to predict something and make money off of it. You might be in an industry, you might be running a business where there might be many different use cases and you want to balance all this out, right? So this is even more challenging because maybe you are in an industry where you can create 10 or 20 different products of the same data, right? But in each case, these requirements would actually change depending on the product you want to create. So again, the point is not that it's very difficult to plan everything in advance, right? And say, yeah, this is a perfect plan. And that's not really the purpose of a data strategy. A data strategy is there to help you keep in mind what can go wrong and inoculate against it, right?
What I was thinking of in terms of, I suppose, something I would want to do in this context, so it was a football league season. At the beginning, then anybody theoretically can win the league. The reality is everybody can't. There's probably 4 or 5 teams that can, and we just use our brains to work that out. But is there an indicator, say, a quarter of the way through the season, halfway through the season, 3/4 of the way through the season, where you can begin to place a bet based on the data that's shown up partway through the season? So it's quite a generic data set rather than the individual match or the individual corner in a particular match. It's more predicting what's going to happen based on, if we look over the last 50 years, a quarter of the way through the season, then the teams that were doing really well 90% of the time went on to win the league. A quarter of the way through, you can predict that. So in effect, the following season, when team 1 or team X gets to match 12 in the season, I've now got a 90% certainty that they're going to win that league. So I'm prepared to put a £1,000 bet on it because the risk for me is massively reduced based on the data that I've got access to.
Yeah, look, so what you're saying about risk now, when I'm talking a little bit about the big picture, something which is not addressed in that often, and should be addressed more often, is not only the performance of a model, but the variance in the predictions of a model. So this closely relates to interpretability and transparency, and this also relates to algorithmic bias and some of the issues we mentioned in the previous session. That is, when a model makes a prediction, how confident am I in this prediction, right? And why did it make this prediction? So I think what you just outlined is a special case of this problem. But going back to the data and data management, which is what this session is about, usually it doesn't come down so much to the algorithms as it comes down more to the quality of the data you have, right? So again, moving forward, anyone who's is facing a particular data challenge, make sure that you deal with this like 4 topics. Someone might argue that say, hey, I have my own checklist with 10 points. That's great, but I think these 4 points are the bare minimum before you even get started with something. So
I think there's an interesting ethical point to this as well, just to look at a different perspective. If you're taking bets and it's based on probability, then you, as you just mentioned, you've got a risk, you've got accuracy. So the question then gets down to what is an acceptable limit of accuracy? And if you're taking bets, what's the spread of that bet? So in terms of, is there a 10% accuracy, 10% inaccuracy? I mean, from a business perspective, as you say, garbage in, garbage out, it's the data and the quality of the data that matters. But also in this business model, in being successful, not only is it the accuracy of the data, it's the predictability. So looking at all of this here, I see many, many challenges in terms of that data accuracy and predictability. And then in terms of actually placing a bet, taking your use case here, how many corners will be won in the second half? If it predicts that there's only going to be 2 corners and there's 3, I think it was Chris who mentioned variability. then if you've taken a bet on that, do you get a refund, or do you actually say, okay, well, there's 3 and we predicted 2, but that's it? So from a ethical perspective, you got to look at the ethics in the data as well.
Yeah, I mean, I guess regarding betting, there's not such a huge ethical risk, but I guess the same type of logic can be applied in the medical domain, for example, right? Where you also face the issue of asymmetric costs, right? So a false negative is not the same as a false positive, for example, right? So if you make, so this means that if you say that someone doesn't have a disease, when they have it, it's probably more disastrous than saying, oh no, they're, you know, they have the disease and then they just do a test and another test and you see that they don't, right? So there's clearly an issue around this. So I think that's a very good comment. But this doesn't necessarily always relate to the data. I think these are also issues. This issue relates to the models themselves and actually the domain, because, you know, in the medical domain, someone would say, hey, you know, there are asymmetric costs and we care more about false positives, false negatives, or something like that. But in other domains, it might not be the case, right? Something which many data scientists are not aware of. So if you're planning to employ someone, it's good to be aware of this, is that unless you really are familiar with the domain, the usual assumption is to say, yeah, the costs are like equal, and this is usually wrong, right? Which is not what we need in many cases. Anyone else before I move on? Okay, cool. Yeah, so I'm going to move on so we don't run, we don't try to not overrun. So yeah, a basic distinction, I'll just quickly mention this: quantitative versus qualitative data. If something is in numbers, basically it's quantitative. If it's like text, video, audio, etc., it's qualitative. That's I guess most people are familiar with these definitions. For a long time, quantitative data dominated the space until recently with the commoditization of various services. We now have the potential to analyze qualitative data like text and images and video in an objective way. So qualitative data has become more and more common, and there are like many businesses working on analyzing huge chunks of NLP data, for example. And there are many problems around data, and now we're going to start talking about a few of the things that can go wrong. So in general, the workshop takes a bit of a more pessimistic tone, so we talk a lot about the things that can go wrong, simply because if you talk about the things that can go wrong, then it's easier to inoculate against this and make sure that everything goes right. And this is at least not exhaustive as to problems that can show up with data, like data not being recorded properly, noisy, absence of documentation, very rarely seen data documentation. It's very, very rare occurrence to see data documentation. Legal risks, quite often something which you find in many companies, the data is being held in disjoint places. So I say a specific person here. I think that's a bit rare. What's more likely is that you see data being held in different sources and not being easy to consolidate. And something I'm going to talk about is different examples of data collection from different industries. And the purpose of these examples are to give you the perspective. Again, the perspective we're always taking is that of a decision maker, right? So I'm not going to show you a real data set, but let's say that you are you're thinking maybe to start a business in an industry like this, right? And then you want to know and then you want to work with data scientists, and you need to know what the data is like. So you want to know how to proceed and what to do, right? So so I'm going to explain the pros and cons for someone who is in this position, right? So let's say you want to start a business in this area, for example, and you want to work with a data scientist. And let's start with the example of a business to consumer app, right? An app on an iPhone or Android, like online dating, it's you know, it doesn't matter, right? So one of the key benefits in terms of the data in this kind of apps is that the data is very accurate, okay? Because there's no human involved in this process. But one of the cons is that the data is not properly structured, and it can take a long time for someone to either understand the structure or to understand how to wrangle the data in order to make something useful with it, right? So I've faced a situation in the past where someone wanted me to analyze some data collected from an app, and they were using some kind of service to collect the data, and this service was essentially collecting every single piece of action, right? So there's this belief that more data is always better, but you have to take into account that more data means that when you hire someone, they might find it more challenging to do something with this data, okay? So this is, for this example, B2C. Then let's say we're talking about a CRM system, like a sales system, right? So one of the benefits of a CRM system of this type of data is that they're easy to understand, right? So don't underestimate the complexity of understanding a new domain for someone who's not an expert in this domain. So some of this data, and the good thing is that this data is easily interpretable, but it's not always clear how to use the data to answer the question, right? So for example, if you have notes on a CRM, how can you make the most of it, right? Then retail. Retail data, I think it's relatively straightforward in most cases, but there are many legal issues around retail data. So ideally, data scientists would like to have personal identifiers, but this is probably not very easy to do any longer. Then data in finance, if we're talking about the stock market, there's really no downside. It's the perfect type of data. And because it's a super structured, it's standardized, very easy to use. If we're talking about other types of data, like other types of areas in finance, like private equity, then things are a bit more complicated because the data can suffer from some of the problems we outlined earlier, like noise, etc. And then sports, we already saw an example in sports. The good thing is that the data is structured. So if we're dealing with structured data, that is data which is in a tabular format, it's always easier to analyze, but the data is collected by individuals and they can be prone to mistakes and erroneous entries. So football data is noisy, and we just saw an example of this. And finally, social media data. Data collection is automated on social media, but there are many, many issues because when you're dealing with language, and especially language on social media, which is full of mistakes and issues in grammar and syntax mistakes, then the data can be very, very messy, okay? So before I move on to the next session, I'd just like to stay a bit here and make sure that no one has any questions or ever understands these slides. Again, what I want to show you here, and again, I'm gonna share the slides with you as well, is to show you the variability between different domains, right? And because I think when someone wants to work with data science, whether we're talking about an organization that has been going on for 20 years but never had a data science function, or whether we're talking about an entrepreneur who wants to start a new business, quite often they make all kinds of assumptions around the data and the types of data and how easy it's going to be to start working with data, and they ignore many of these details, right? So if you're not a data scientist, maybe you don't really understand why it might be more challenging to wrangle JSON data compared to structured data, right? But what I want you to take from this is to take a note of all these points and say, hey, you know what, maybe I should ask about this. Maybe I should keep this in the back of my head, right? Because this is going to not only advise your data strategy, it can have a huge effect on how you're going to go about solving a challenge, or building a business, or building a data science function within your organization. All clear? Okay, so if there are no questions, yeah, sir?
No, that's good, thank you.
Okay, perfect, thanks. So I'm going to move on and talk a bit about data management, and I'm going to present you a few funny case studies as well, right? So again, in data management, there are good and bad practices, and it's very simple. I mean, these look pretty simple on paper. In practice, things go wrong very often in various ways, sometimes traumatic, but the good practice, a good practice is that when you start working with data, you have at least one concrete goal or question in mind, which can act as a northern star to what you're trying to do. Try to also understand the interaction between data science and the business part, and also have some kind of documentation or a data standard. Then a bad practice is when you don't have a clear direction, when you're not aware of the interrelation between data and business, or when there's no documentation, right? And here's a very simplistic example of a bad practice. Okay, so let's say that you want to create an app. I mean, you know, this example doesn't have to be about entrepreneurship. Maybe you're an established business and you want to do this, it doesn't matter. But you have an app and then you help users find restaurants, and the registration information exists in a structured format. And you have 3 types of variables: the name, the age, and the app interactions, okay? And so let's say that you run this app for a year, and then you hand over the data to a data scientist, and you ask them for some help to get some general insights. So what is wrong with this approach so far? Anyone?
Can you just go back to the last slide, please?
Sorry?
Can you go back to the last slide?
Oh, yeah.
Yeah, thank you.
Yep. Any ideas, Paul?
You've got a very limited data set.
Yeah, I mean, the data set is limited. This is what I was going to go to next. The point I was trying to raise here is something which I've seen happening very often in practice, is that a company is looking to get help from a data scientist after they've built this and they've collected some data, but they didn't think about asking help from a data scientist before they started collecting this data, right? Because the data isn't optimized for any particular goal, right? I've heard many times people say, "Oh, I'm just collecting data, and you know, then I want to hire a data scientist to help me out." And then this means that the data scientist will lose time to come up with interesting ideas. You have to do data wrangling, and no skill might make data wrangling even more difficult, right? So it's a good idea to start working with a data scientist or an expert before even you start collecting data, not after you've made some random assumptions about the data, right? And then the second example is actually, you know, what I was looking for the answer you just gave me. But let's say that the app actually wanted to create a recommender system from the onset. But the problem with this, with the current data, is that the data again is not optimized, right? And they're set up in the wrong way. JSON is probably not the best format. This is not catastrophic, right? I'm not saying that any of those mistakes are catastrophic, because in software, you can always solve things, right? Even if a system is humongous or chaotic. But you correctly noted out that there are very few variables, right? And again, this goes back to, these are like some simplified examples of cases I've encountered in practice, right? Of companies not having the right data because of the lack of data strategy, or not having a particular goal in mind.
For me, that's the big one. It's starting with the end in mind. Unless you know what you want at the end, and sometimes you don't know what you want at the end, so you need some challenge on that one. But I think you've got to have that discussion up front. Otherwise, you're going to collect probably the wrong data and probably in the wrong way.
Yeah, exactly. So this is something that unfortunately is happening again and again. Plus, another mistake I've seen many businesses doing is that they think they know what they want, but they don't have the right KPIs in mind. Right? So this is another one. And here's a funny cartoon to lighten up this evening. Which again, it's something that you might encounter in practice in one way or another. And this is another example of a bad practice. Yeah, sorry, this extends like the previous case. There's another one I'm going to present later, which we're essentially, what I'm saying is that there's not enough information, and what you want to do is you want to make sure that you plan in advance, which again is common sense, but not everyone is doing, right? And there are many considerations, from the data engineering part to the data collection to the KPIs that you need to look for. And I just think that for many businesses, data science is often an afterthought. Okay, I see this a lot in the space of startups and scale-ups. Usually companies are looking into data science 2 years after, for example, they've been operating. And then like a note here, don't buy the hype. So there's like new technologies all the time. Sometimes they're useful, sometimes they're not. There's this very interesting article. Again, I'm going to send you the slides, called "You're Not Google," which explains some of the cases of when You shouldn't be looking into some of the fancy solutions, various databases, etc., simply because the challenges you face and the challenges that LinkedIn or Google are facing. Okay, and something which I've stated, I'm going to state again, is that it's not always easy to think in advance of all the kinds of data that you might need for solving a problem, but it always pays to do this exercise or to use tools like the data strategy canvas and to consult a data scientist before you even start. Something else I wanted to, yes, sir?
Sorry, yeah. One of the challenges I see is that organizations collect too much data. So going to your point around a data scientist, if they can't afford it, they'll collect anything and everything that they can.
Yeah, so I think there's this notion that more data is always better, but there not many companies are aware of, what's the quality of the data, what's the goal behind the data. So if you're just collecting anything and everything, then there's obviously going to be an additional overhead in processing this data, right? So lost time and lost value, which is not needed. And quite often, a company might have 1, 2, or 3 use cases in mind, and they've just been collecting lots of data in the wrong way, which they didn't need. Now, if a company actually has the money or the resources to collect everything, and then they can just hire people, hire an army of data scientists and engineers to help them out, that's fine, right? But in many cases, this is simply not what they can do, right? And there's also a scientific reason, because now we're talking about data wrangling, data engineering. You don't always want to add more data into a problem. You want to add more quality data, because if you simply add more data blindly, then the performance is going to get, quite often it gets worse, whatever it is that you're trying to do. And there's actually a scientific reason behind this, which means that more data is good, but we should never underestimate the overhead required in understanding where the information lies within this data. Yeah. So yeah, something else I wanted to mention is the next point is it's important to understand how data interacts with the business model, and something in which is quite unique to data science in a way is that data science interacts directly with a business model in contrast, for example, to software development. What this means is that in data science, the way that you design the user experience, for example, or the user interface is going to directly affect the way you collect data. And I'm showing an example of 2 dating apps. One is Tinder, and the other one is OkCupid. And OkCupid is a dating application that is handing over a very long form of questions to the users. And it's like a very long personality questionnaire, more than like 100, 200, 300 questions. And this can be used to create the perfect recommender system, but it makes for a very, very awkward user experience. Someone really needs to sit through this in order to answer all of the questions. Whereas Tinder has a much more simplified user experience, very basic recommender system, but it has become more popular simply because the user experience is smoother. So this means that data science is not always king, right? So maybe Tinder made a strategic decision not to focus so much on data science, but to actually, in order to create a very smooth experience. And again, it's about understanding all these interactions. And you can see this, you see this a lot in marketing. Here's an example from an app that helps you find concerts. And you can see how, for example, when someone clicks on an artist, they can see different options like I'm attending, maybe get tickets, share. So when you're a data scientist analyzing this problem, you are dealing with the challenge of trying to trying to figure out what's the value of each action and what this means for a user. And I remember when Facebook, they rolled out, once upon a time there was only a like button, and then they had rolled out like 5, 6 different likes. And essentially they did this in order to get more granular data. And I remember everyone was like talking about this. Facebook has different kinds of likes and blah, blah, blah. Now LinkedIn has done the same. And these are like some very small tweaks that platforms are doing, but they can contain a wealth of information. So and actually the point here I'm trying to make is that the interface and the user experience and the business model can interact very closely with data science. And quite often there's a trade-off, as we saw in the previous case. So while a data scientist might advise you to do something like OkCupid, maybe you actually need to do something more like Tinder, for example. I mean, there's no generic guide to this one. And again, the point here is not to tell you this is what you should do, you should focus on the data or this or that. It's more about for you to be aware of how data science can interact with the business model. And in some cases, maybe you have to accept that data science is not going to work out that great, but it gives you, but if it might not work that great, but you are using a great business model, right? So data science might still give you an advantage, but you know, this doesn't matter as much if your business model is working well already. Any questions so far? Or any comments? Okay, so if there are no comments or questions, I'm gonna move on and talk about tidy data. I hope you like this image. I think it's pretty funny. Dirty data versus tidy data. Okay, so this is a very important distinction. And again, you're probably not gonna handle data yourselves, but it's good to know about this. And dirty data is data that's like erroneous, it has conflicting entries, outdated entries, and this data is very difficult to use in many different ways, right? Difficult to consolidate, to analyze. And most problems with dirty data can be attributed to the following, like different departments handling the same data sets, lack of documentation, or lack of communication between parts of the company. Usually the bigger a company, the more likely you're gonna encounter dirty data in one form or another. Now, this is another example coming from my experience in the past. I worked with a football club some time ago, and they gave me data. They had different departments, and each department was handling different data sets in Excel. So there was no consolidated system, right? And the goal was to use the data in order to predict injuries, but there was no way to do this when the data was not consolidated. So there was not much communication between departments, and there were some like really crazy things happening. For example, someone might have been noted down as being injured, but he was actually playing, right? So some of the data was just wrong, right? And there were no established procedures for recording the data. Sometimes data would be overwritten, like doctors would give like different diagnosis and say, hey, I revised this diagnosis, or another doctor will revise some other diagnosis. And essentially there was about 6 to 12 months wasted fixing these issues and trying to come up with a centralized solution to store the data, okay? So eventually the problem was solved, but for like that year, the work was not so much around data science per se, but it was around fixing the culture of the company and setting systems and processes in place, because the technology that was employed was not even that advanced. Any comments? Because this is the end of this session around data management. Is someone writing in the chat? Okay, perfect. So I'm gonna move on to, does everyone agree to move on to the next session and then maybe have a quick break?
Yes, good for me.
Sounds good.
Okay, cool. So this is my favorite session. Okay, let me share my screen again, the different deck of slides. Give me a second. Where is it? Okay, it's here. So this session is called Thinking Like a Data Scientist Without Being One. Okay, and this is my favorite session because it really talks about how you can structure as a decision maker's problems in data science and think about solving them. Okay, and I'm gonna show you like the full process and the framework for thinking about these problems. And here's the session outline. Okay, so we're going to talk about the data science process, then we're going to talk briefly about statistics and machine learning, then about problem solving, and finally about some of the pitfalls, okay, that you might encounter. So let's start with the data science process. So this is a very funny image, and I'm gonna give you a few seconds to look over it. What different people think data science is. Then, there are different opinions about what data science is. This is what this image is trying to say. And the correct image is that data science requires the harmonization of many different parts, right, within an organization. I don't know if anyone objects. Maybe some people think that data science is more like, you know, a magic rabbit coming out of a hat. If anyone believes this, then please raise your hand. But really, data science is an exercise in balancing many different aspects. And a pragmatic definition of what data science is about in practice is that it's about 5 different things: collecting, organizing, analyzing, interpreting, and communicating findings from data. And data scientists usually do 3 to 5 because sometimes they're called upon to analyze data that is already there. So that's a very important slide. Please take note. Obviously, you're going to have the recording after the end of the session as well. There are 2 main actors in data science: the domain expert and the data scientist. Okay, so domain expert is you, right? If you're going to employ a data scientist. And there are 4 different parts, and for each part, there is one or person which might dominate, or the 2 have to work in synergy. So the problem definition is what the domain expert ideally should do. So the problem definition is that happens by you or by a data scientist who knows the domain really well. But this is what this session is about. This whole analogy of AI superpowers, this is what it's about. It's about you being able to define a goal and say, yeah, this is how I can use data science. This is what I can do using data science. Choosing the right data goes back to the previous session. It's about the data management, right? Then the solution to the problem really comes down to the data scientist. And finally, creating value through actionable insights requires both parties. And this is where having the right people and having the right culture in a company can play a huge role. And now I'm going to give you a very simple, and I'm going to give you a simple example following these 4 steps: problem definition, choosing the right data, solution of the problem, creating value through actionable insights. The example is pretty mundane. I just couldn't come up with anything better that everyone would resonate with, and at the same time being maybe a bit funny, depending on what you think about it. But let's say that you want to study a problem, okay? You want to study a problem using data science. And let's say you want to study the problem of consistently late starting meetings, which quite often is also occur now in the days of Zoom. Somehow people still manage to be late, whatever. So a good way to start about this problem, to answering this question, is to write it down as a question, okay? Write it down as a question, which might sound a bit like simple, like why would you want to do this? But it really helps to crystallize what you're trying to achieve, right? So instead of saying, I just want to study late starting meetings, which is what most people would say, you would have to say something like, is it really true that meetings start late? Okay, because just saying I want to study late starting meetings, it can have, it can branch out to many different problems. And this really helps a data scientist focus. Then think about the data. Okay, so how are you going to collect the data? And this is where it really pays off to write definitions of the protocol, which not many people do. And this is very important to write these definitions. The reason being that something that can go wrong is that if you don't write the definitions, then you have different people working on a problem, then you might end up with entirely, with solutions that don't make much sense. For example, if let's say that it's small talk that's delaying meetings, for example, and you didn't really take into account small talk when recording the time of the meeting, then you're just never going to find a solution, right? And this goes back to really recording the right variables. And I'm going to show you an example from real life. Actually, I can mention this now. There was this company I consulted for at some point, and they wanted someone to analyze some data for them, and they wanted to understand gender differences, but they hadn't recorded, for example, gender as a variable. And we have to try and infer this from the names, and obviously many names are the same for both sexes, like Sam, and in the end we had to throw away lots of data. And then something important is to make sure that you can trust the data, right? So you can, and it's very important in order to document the steps. And again, this might sound trivial, but for example, you get cases where A and B might use the same terms, but might refer to different things. So an example of this kind, I encountered this in the previous case study with football, where let's say that you have someone in a medical department recording data, right? And you have a single person who's responsible for this data, and they're not following the protocol. Maybe they're following their own judgment. And then at some point, this person then leaves their job and there's a new person hired. And then this person uses slightly different judgment in order, it uses like some different, not judgment, sorry, it uses different criteria to store the data. So in this case, you have, let's say, 100 data points recorded by person A, and then 200 data points recorded by person B. And there's slight differences between the data points. So what this means is that you might have, let's say, a variable, and this has been recorded in slightly different ways, right? So, for example, I had helped a company in the past that was using radar data, and they were running experiments. It was a sleep tech startup, so they were measuring someone's quality of sleep, and they were, and what they were doing is they had a radar device to record someone's like respiration and heart rate while they were sleeping, and then they updated the device, and then they gave me data from the first device and then data from the updated device. And the algorithm was very confused, obviously, because the quality of the data was very different. There was noise in the data, and the type of noise was very different between the devices. So the point I'm trying to make here is that these kind of problems, they can take place quite often in practice. And then something else, like when solving the problem, this really comes down to the data scientist, but something which I really insist on that decision makers should do when working with data scientists is to start with exploratory analysis, because data scientists, quite often their instinct is to start doing some complicated analysis, but these analyses are not always easy to understand, right? So this is why it's better to go for exploratory data analysis like graphs, charts, which are more straightforward and easier to understand. And then obviously the final, the next step in the solution is to try to answer a specific question. And this is where you want to go and revisit point 1, right? The question set out to answer, and at the same time, set out a number of secondary questions which can benefit you in other ways, right? And I think this is where good data scientists really shine. I showed you at the beginning this diagram with the different skills that the data scientist should have, and I also mentioned that one of the skills is the soft skills, like business understanding, coming up with good ideas, etc. And this is where a good data scientist really shines, in coming up with all these secondary questions which can add value to a business. Again, this is a toy example around meetings. In practice, it's going to be something more complicated. And always, the important thing is that the problem should connect to actionable insights. It should connect to KPIs. And it's the data scientist to help you understand the impact of the results, which should either be something which is measured in monetary terms or in something actionable, as in, if the meetings are late because of one person, let's kick out this person, something like this. And again, this is somewhere where the business understanding on the part of a data scientist plays a huge role. This is where the culture of a company plays a huge role in helping the data scientist communicate this. And this is a point where many companies miss it, right? Unfortunately. Here, I'd like to take a pause and try to go back to the data strategy canvas, which I gave you, and think about a specific strategy or challenge that you want to solve if you haven't done already. And maybe if you want to revisit after what we've mentioned, the 4 data considerations that I outlined earlier. Yeah, I'm going to give you a few minutes to fill this out if you want. And again, if you don't want to do this or if you're tired, that's fine, because you can also send this to me after the end of the session, tomorrow, next week, whatever, and I'm more than happy to review it. Yeah, so I'm going to give you, let's say, 2 or 3 minutes, and I'll come back. All good. Anyone who did this, like try to pose their challenge, trying to solve as a question. I mean, maybe if you're facing like some more general problems or you don't have a specific challenge in mind, that's fine. But if you want to do this exercise, and happy to talk about it now, happy to talk about it also some other time. Yeah, someone wants to talk?
Hi, Stelios, Brandon. We'll pick ours up at a later date. We've still got a lot of user interviews to do, etc. So I must admit, I got halfway down the paper and then sort of got stuck.
Sorry, I couldn't hear you very clearly. It's a bit noisy. You got half down with the paper and?
Oh, sorry. I said I'll pick it up later. I got halfway down the paper and then we got stuck a little bit because we still need to do a lot of user interviews to understand what they're trying to get from the data.
Okay, so essentially you're like even before this stage. So it's like, it's not like you have a specific challenge you want to solve. You're like, okay, what should the business actually do, right?
Well, we sort of know the problems they've got, but the roadmap to get there, the data they have is so bad that we really have to dig into what they really want to solve.
Yeah.
There's no way we can achieve their high level goal they want to achieve. So we have to try and do some intermediate goals to get towards that. I think that's the strategy we have at the moment.
Okay. So I guess that this is a more complicated case because you're not just facing a single challenge, but you're actually facing a business challenge first of all, right?
Yeah. So to get to the ultimate goal, we've got to solve lots of little goals to get there, and obviously collect better data.
Makes sense. Okay, very good point. Very good point. Yeah, and I guess it goes back to the point I mentioned earlier of how data science interacts with the business. So in this case, business is obviously the priority, right? Not data. And then data is obviously going to get you there. Great. Anyone else? Okay, if there's no one else, then I guess I'm going to go on to the next session. And then after that, we can have a short break. I think we're pretty much on time, so that's great. So this is a short introduction to statistics. Again, this is more about understanding statistical science from a high level, and many of those things will come in handy when you're trying to think about how you can use data science to solve a particular challenge and what kind of person you should hire. Something important to state is that there are two types of statistics, and we have descriptive statistics and inferential statistics. Okay, and most people think that statistics is about descriptive statistics, things like charts, graphs, etc. But in reality, most data scientists work with inferential statistics. And descriptive statistics is about organizing, summarizing, and presenting data. And most people are like, they know about these things, like the mean, the median, charts, etc. But inferential statistics is where most of the magic happens. And inferential statistics is about modeling and drawing conclusions from samples of data. So the important thing around inferential statistics is that it allows us to quantify uncertainty and draw conclusions about the population from a sample. And there are two pillars of inferential statistics: statistical modeling and hypothesis testing. So the important thing with statistics, if you recall, is that statistics allows us to handle uncertainty and create interpretable models, right? So if you're in a domain where you really care about understanding cause and effect and how variables are interconnected, then statistics is a much better solution than machine learning, which is more opaque, it's less transparent, okay? So my guide for decision makers as to how to use inferential statistics is to use them to answer particular questions about variable importance and to answer questions about differences between populations. And in practice, this happens very, very often. If you want to do A/B testing, if you want to compare things around your users, or if you want to identify which factors lead the users or other entities to make certain decisions. So it's very important for you as a decision maker to understand whether, because statistics is always used to make up a hypothesis or a story, it's very important for you to understand whether something can be answered with statistics and to understand whether the story makes sense. And again, that's a very important slide. Maybe you want to keep a note of it because it gives you some heuristics as to when to use hypothesis testing, when to use statistical modeling. And hypothesis testing is used when the value of a population. So when you want to understand something about the population by using a sample, right? Or you want to do comparisons like A/B test, or like what's the differences between a group, right? So when I talk about the value of a parameter of a population, I'm talking about things like what's the average income in a country, or other related parameters. Then statistical modeling is much more interesting because it can tell us how a variable affects another. And something important to note here is that in many business cases, many businesses, what they care about is simply statistical modeling, understanding how variables interact with each other. But quite often they're like, oh, we need someone to do AI. And I mean, no, right? So it's actually doing statistical modeling is much cheaper. It can be very effective in many cases, so you don't always need to go for the big guns, right? And then forecasting deals with predicting future values. Hypothesis testing, I don't want to go too much into the technical details. I think I'm gonna go into like a few notes about statistical modeling. This is George Box. who is a very famous statistician, who said that all models are wrong, but some are useful, right? And when you hear about a model, it doesn't matter, you know, what fancy name someone is using for a model. You always have an input and output and some assumptions around the model, right? And essentially, the magic behind statistical models is that they're very good in handling noise, okay, through statistical inference. So the model will never be perfect. It will never make perfect predictions. You never, I mean, if you want a system that has 100% accuracy, then data science is not for you, okay? Data science will very rarely make perfect predictions, but it can help you handle uncertainty in a way so that you can create a system that works well enough for, you know, you to make some profits, to increase the margins, etc. And the statistical model that most people are familiar with is linear regression, which is abused in most cases because it's used in the wrong situations. If you see someone who who claims they're a data scientist and the only thing they know how to do is linear regression, then please run away from them. And then there are, and essentially the different types of statistical models differ in the applications and the assumptions they're making. So I'm not going to go into much details about this. If someone wants more details about this, very happy to provide more context after the session. If you just send me an email, happy to obviously answer any questions which you might have. And then forecasting deals with predicting values in the future. It's been called a bit of a black art, and that is because it really is a black art. And these days, forecasting is quite often taking place through machine learning. And one point I want to make around forecasting, I think it's an application that is fascinating for many people. It's predicting the future, understanding where the future is going to go to, whether we're talking about the sport market, whether we're talking about political events. But you see here a graph from a forecasting model. And the thing that stands out is that you see that the model, you have data up to here, which is 2011, let's say. And then the blue line is the predictions, right? And then the shaded areas is the uncertainty around the predictions. So what you see here is that as the model tries to predict points which are further and further out into the future, then the uncertainty after a point, it explodes, right? Which essentially the model is saying anything can happen. So this shows you that in general, as you might have guessed, it's very, very difficult to predict things far into the future. It's one of the reasons that many political campaigns fail. And I also have an example to show you around this later on. A very interesting example as to how, when Brexit took place, and when the Brexit vote, because Brexit took place recently, and when Donald Trump was elected, how many pollsters got it wrong and why. So misleading with statistics. Any questions so far, by the way? If anyone wants to comment anything, feel free to chat or raise your hand. Again, I'm trying to provide you an overview here. If anyone wants me to get in more depth, because we're online, we're a bit more restricted with time, but if anyone wants me to get in more depth, feel free to get in touch directly, and then happy to provide you with any details. So misleading with statistics, and as you see, I've added a funny cartoon here, which describes what's happening in practice quite often. And people get very pressed by simple graphs and charts, which do not necessarily mean anything. And here's another funny example, right? So these are some real graphs, and you can see here that the number of people who drowned by falling into a pool correlates highly with the number of films Nicolas Cage appeared in, right? And as you can see, the two lines follow each other very closely, and there's indeed a very high correlation. But obviously this is nonsense, right? So this is taken from a site, tylervigen.com. Let me write this in the chat. This is a site that deals with what we call spurious correlations. These are like correlations between variables that do not really make sense. We know it doesn't make sense because we have an understanding of the world and the underlying system. But that being said, the numbers, the statistics, they do not know this. So we think this makes sense, right? And in practice, you encounter these stories, these kind of problems very, very often. So can you actually think of a field that is plagued with these problems?
Yes, your comparison of the data sets.
Yeah, but I'm asking about the particular domain. There's a particular domain where this is a real plague, this type of problem, like spurious correlations between time series. Anyone?
Like something like public health?
Yeah, public health. Actually, I was thinking more of finance, but public health could be another one. Like in public health and healthcare studies, you hear about all kinds of correlations, and they change every few years, the health standards, and whether you should eat this or not eat that, and all this kinds of stuff. So that's a very good one. Sorry?
Hospitality industry as well, or travel and tourism, in terms of correlation with things.
Travel and tourism, I'm not sure. I'd have to think about it. Finance for sure, because in finance you have many time series, and if you're dealing with thousands of time series from different stocks and products and commodities, then you're bound to find some correlations by accident. And there were even a couple of guys, the statisticians, that wrote a book about this, saying how the financial crisis, one of the issues was that portfolio optimization methods which suffered from spurious correlation. So in general, do not always trust the data, right? I mean, trust the data, but do not always trust the interpretation of the data. And here's another example of how someone can lie with data, lying with charts. So these two variables, they're the same, but you see that the right one, we've used the transformation, a logarithmic transformation, to make these things look closer than they really are. Something which happens very often in practice. Another ridiculous example, you can, by zooming in and out of a picture, you can either show that there is a linear trend or not. In general, you see these kinds of things on the news all the time, right? Descriptive statistics, like the two most popular ones is the mean and the median. If you're talking about symmetric distributions, the median is the same as the mean. Otherwise, they're different. And one of the most common abuses of these statistics is when you're reporting income, if you report the mean, then it's more likely than the average income is going to be higher than the median income. So if you're talking about a country or a company that's very unequal in the pay, the median is going to give you a more accurate picture, whereas the mean is going to give you a more skewed picture and make you believe that everyone is earning more money than they are. And then there are some certain biases which can take place in statistics, in sampling. This takes, you see this kind of problems very often in the domain of marketing, I guess, maybe also in health. It's very tricky because in order to identify, my screen is running my memory, because if you, because these problems are difficult, you can't really identify them easily through the models themselves, right? So selection bias is a very famous, I mean, most biases in this context are like derivatives of the selection bias. And selection bias is essentially the core bias, which someone can find. And this is a very good example. In World War II, Abraham Wald, who was a very famous statistician, he was called upon to increase the survivability of US aircraft. So why would they call upon a statistician? So what the US was doing at the time is they would reinforce with armor parts of the plane that they had been damaged. So planes would come back to the base and they would have been damaged, and then they would reinforce those parts with armor. So what was wrong behind this idea was that it was a clear example of selection bias. Because if a plane was damaged in a certain part and could still fly back to the base, then this part was non-essential to flying, right? Or it was, you know, or somehow it could still, you know, survive. However, the interesting planes were the ones that were shot down because these planes were hit in vital parts for the airplane. So what Abraham Walsh realized is that they should be doing the exact opposite of that, what they were doing. The sample they had of the airplanes that were coming back to the base was completely biased. So what they should do is reinforce with armor all the parts that were damaged. They should reinforce with armor all the parts that were not damaged. Because if an airplane had been damaged in those parts, in a part like this, then it would have gone down. This is what's called survivorship bias. Can someone does someone know where else you encounter survivorship bias? A lot. Like you see this a lot on LinkedIn, in reports, in studies, on Instagram, many places. Where do you encounter this type of bias? Anyone? So I'll tell you the answer, or does anyone have any ideas? Okay, so one case where you meet this bias very often is in studies of companies or entrepreneurs who succeeded. So when you read articles like what 10 companies who succeeded are doing, what like most successful entrepreneurs are doing, and blah, 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 blah. What these articles are not telling you is what all the other people who failed are doing, right? Because in order to learn something from a data set, you need to have a measure of comparison. You need some variance. And if you only study cases of those who succeed, then you're learning nothing. Then we have area bias, which is when you try to generalize results from one area to another. Very common problem. Self-selection bias, especially in case of selection bias, it takes place a lot in marketing. When, for example, you try to, if you want to ask people a survey about something, and then whether they want to participate or not, it's their own choice. Quite often you get a certain group of people who are very much interested about this topic. Then leading questions bias, that's very well known. The sequence in which you ask questions can affect the answer. Social desirability bias, if you ask people how often they shower, they're going to give the wrong answer, how many cigarettes they smoke, how much they drink. These statistics are never 100% accurate. People are usually reporting something false, especially if they're asked by a human. And sometimes all these things come together and they can cause big issues, right? So when pollsters failed to predict Trump's election and Brexit happening, it was a combination of all those biases coming together. And since then, pollsters have been criticized again and again. I think they've become somewhat better. Like we didn't see any major, I mean, we still saw some issues, but nothing as major as back then, because back then they really missed predictions by a lot, right? Okay, I'm going to skip over this. And I guess we can maybe have a break here. And what I want to share is also want to share a post around this topic of how biases in practice can cause various issues. And it was a post from the scientist. Let me find it. Okay, so find this. Okay, you can find this here. Perfect. So let's have maybe a quick break and then we can continue. I think we're going to be pretty much on time. So I'm happy about this. Yeah, does everyone agree?
Yes.
Okay,
yeah, sounds
perfect.
good.
Let's reconvene in like 10, 15 minutes, yeah? Perfect. Hello again. I'm back, 7:30. So Brandon has asked an interesting question. The housing crisis is highly politically charged. Not so much bias, but deception and interpretation. There's danger of data, and the rest to suit their own purposes. Yes and no. Like organizations and governments are already using data to support their own agendas, right? Releasing open data can help, but I wouldn't say it's the perfect answer. I mean, it does help, but what we've seen with COVID, for example, is people coming up with their own interpretations of what's going on, right? So it can help, but it's not the complete, but it's not the only answer, yeah? So shall we move on? Yeah, okay, I think we're more or less on time. Maybe we're going to overrun slightly, but I don't think we need the second session. But obviously I'm planning to catch up separately with all of you after the session. Just making sure, is everyone here? Okay, I think people are here. So I guess, yeah, perfect. So I can go on. And now I'm going to take you through a short introduction to machine learning and present you with some heuristics as to when to use machine learning and how, right? So these are some definitions of machine learning. I'm not going to spend too much time on them. But essentially what all these definitions tell you is that machine learning in one way or another is about optimizing based on past performance, right? And machine learning is developing methods which can detect patterns in data, okay, and make predictions. And machine learning, as the name implies, it's about giving the ability to machines to extract patterns from data. And there's an example I really like to present, and this is a toy example. If you ask a human, if you show a human this data set and you ask them, which group does this object belong to, they will be very quick to say, hey, this belongs here and this belongs there. And we do this unconsciously, and essentially the whole field of machine learning is dealing with how can we make machines do the same thing, right? And your brain unconsciously went through these stages, learning and classification. And if a human does it, it's like, common sense. If a machine does it, it's called machine learning. And obviously the main reason that machine learning has taken off in the last 10, 20 years or so is because we're trying to replicate this unique human ability, which can scale infinitely given enough resources, right? And enough data. And from this very simple idea of how can we get the machine to do this, we've, now have thousands and thousands of algorithms trying to do this exact same thing, whether we're talking about language, whether we're talking about images, whether we're talking about other things. And there are different types of machine learning. The two main ones are supervised and unsupervised learning. And that's an important distinction. And it's one of the things I'd like you to take from this lesson, from this workshop, because it really, if you understand this distinction, you'll also be in a very good position to understand what you can tackle using machine learning or not. So these images, they show you the differences between supervised and unsupervised learning. And as you can see in both cases, you have an input and an output, right? So always with models, we have an input, a model, and like a middle layer, then an output. And the difference between the two is that whereas in supervised learning, there is something which we call a supervisor. In unsupervised learning, there's no such thing. So in supervised learning, we deal with the algorithm learns from data through an iterative manner. And it's one of the reasons that machine learning is so data hungry and so processing hungry. So in order to make a supervised learning algorithm work, you have to give it the data, both the input, but you also have to give it real output. And then the algorithm will learn how to match the two. Whereas in unsupervised learning, the algorithm learns on its own how to extract patterns from data. Okay, and we'll get there in a second. So in supervised learning, there are two branches, classification and regression. And the question behind classification is, does something belong in a category? Okay, and this can mean does something belong in spam or ham, object detection, will a stock rise or fall, will someone click on an ad, will the temperature be below or above 0 degrees? This is one of the most common problems in machine learning. Will someone buy or not, etc. Regression deals with real numbers, right? So instead of asking whether the temperature will rise or fall, you're asking, hey, what's going to be the exact temperature like? Or if instead of asking whether someone's going to click on an ad, you're asking what's the estimated number of clicks on an ad, right? This kind of questions. So this is the basis of supervised learning, and this is the basis of automation. So when you hear about AI taking our jobs or people's jobs, maybe not our jobs, some people's jobs, I don't know, it usually comes down to this, to using supervised learning to automating on a massive scale. Something important to note is that if someone gets technical, they'll realize that they can answer the same problem in different ways. And the answers through which, the way through which they answer the problem might help them, might affect the performance. So going back to the stock market, maybe if you want to make money in the stock market, you can deal with a forecasting problem, or you might deal with a regression problem or a classification problem. All these are viable ways to solve the same challenge, right? And this is something very important to take a note of. This is a very interesting application for supervised learning, which we don't have the time to go through, but because it will go really too late, but it's an application by Google, which helps you play with neural networks to see how the system is learning, right? But if anyone is interested in this, happy to provide more details. Then unsupervised learning. So unsupervised learning deals with extracting patterns from data with no guidance, right? So in unsupervised learning, the ideal is that you would give it these kind of data points, right? Like different animals, and then the algorithm is going to tell you, oh, these are like mammals, they're birds, this is like fish, etc. And there are many applications of unsupervised learning, like from coming up with groupings to detecting anomalies, for example. But unsupervised learning, while it's a very valuable piece of technology because it can extract insights from data automatically, it's very difficult in practice, and it's very challenging. And I'll prove this to you now. So how would you cluster this? If I asked you to make these into groups, how would you go about it?
Vegetables and fruit.
That's one way, but there are more ways, right? So you can say it's green
by
and
color?
Sorry?
By color?
Yeah, you can also do it by color. All these are valid, right? So you can do it fruit and veggie, it doesn't matter. The point I'm trying to make here is that this problem is ill-defined because I asked you to come up with patterns that can separate these into categories, and you came up with different patterns. So which one's the best answer depends upon the problem you're trying to solve, right? And so let's stay here, which means that when you're dealing with unsupervised learning, you always need a human somewhere in the pipeline to judge how good the answer is. And this is the challenge. This is why you don't hear about unsupervised learning as much as supervised learning, which is used for automation. That being said, unsupervised learning, clustering, for example, many great applications when you want to explore data, for example, in customer segmentation, right? So this is when clustering is very, very useful. And then anomaly detection is another example of unsupervised learning. And anomaly detection is a very interesting application in domains like cybersecurity or disaster detection, where you have data and you want to single out suspicious points in the data, right? So here you see a time series and you can see that an algorithm can quickly detect which points seem to be out of the ordinary. That being said, it's again, anomaly detection is a bit tricky, right? So why? Banks have anomaly detection systems to detect fraudulent transactions. So raise your hand if you ever been contacted by your bank because of some transactions you did which were not fraudulent and the bank thought they were suspicious, right? Maybe you go on holiday and the bank like tried to block your card because the bank thought that, you know, your card was stolen. Yeah, so this is where anomaly detection is very useful, but also it can be, sometimes it can make mistakes. So I hope that everyone understands this case. And then dimensionality reduction is another interesting use case, which is, does anyone in the audience know the big 5 personality factors? Somehow when I ask this question, most people do not know about this.
I don't think I have heard of this actually.
Sorry?
I don't think I have. I don't think I've come across.
Yeah, so the big 5 personality factors, they are like the most successful theory of personality in psychology, saying that all human personality gets reduced down to 5 factors. And essentially what this comes down to is that how this was derived is that they ask, you know, let's say a bunch of questions to a large sample, and then using dimensionality reduction, you can group these questions in 5 different categories, right? So this is like clustering for variables. So if you face a situation where you have a very large number of variables, then you can use this technique to reduce them down to 5 factors, as we call them, which are like super variables, right? Again, very, very useful technique if you want to visualize data, explain data. Like if some of you are thinking about data products, for example, using some of these techniques like dimensionality reduction, you can create something very valuable, very fast, right? And then other machine learning systems, recommender systems, very, very, very popular application. If I said that it's the most significant application of machine learning right now, it wouldn't be an overstatement, because everything now in retail and in B2C is about recommender systems and personalization. Whether we're talking about Netflix, whether we're talking about Spotify, whether we're talking about Amazon, recommender systems are everywhere. And then reinforcement learning is a very interesting type of machine learning because it is very close to real intelligence, right? So reinforcement learning, some people believe, might get us down to building real intelligent machines. And reinforcement learning, have you heard about the successes of DeepMind in building an algorithm that beat the world Go champion and that stuff? Has anyone heard about this? Or in DeepMind?
No, not me.
Okay, so yeah, basically what DeepMind did is it's a company in London, and they're working on AI, and they created an algorithm which beat the world champion of Go, which was considered a problem that can be solved. And then they've built other algorithms which can play video games. And so, for example, and I can show you, it's probably worth showing you this one. Let me see. Sorry. How do, wait, I have to reshare my screen. Sorry. So a reinforcement learning creates algorithms which learn from experience, a bit like real life. So you have, for example, here an algorithm that operates in a simulated environment, and then it receives feedback, it receives some reward as it goes along, and then eventually, and then it learns how to navigate this environment, okay? And this technology here, you see it applied on Super Mario, which is a funny example, but in practice, this is used in the stock market, in drones, in robots, and you can understand, for example, how a very powerful model could learn, for example, how to drive, right? So you could create a car that learns how to drive in a simulator, and then you release it out in the real world. Just an example. So now this technology is becoming more and more popular, as you can imagine. Let me go back to this deck. And so there are some people who believe that this might lead to real artificial intelligence, but I'm not sure about this, but it's definitely a very interesting technology. Any questions so far? I'm now going to move on to give you some heuristics about what to use and when. Okay, if there are no questions, I mean, if you have some questions, you can also always email me after the session. So, solving a problem, right? So, this like subsection is about thinking like a data scientist without being one, right? So, you have to try and think like a data scientist when approaching a problem, not because you want to solve it like a data scientist, but it will help you understand what are some of the issues that might arise and what kind of person you should get in order to solve a particular challenge. So there are some common issues which are involved in understanding whether a problem can be solved. That is, having the wrong expectation is a very common issue, and then not having the right data. And a data scientist in the beginning, right? So where you should start is by trying to figure out whether a problem can be solved and whether it's easy or difficult, and the time and resources required, right? So you need to learn how to work alongside the data scientist and be very careful with time or complexity requirements, okay? And never make assumptions, because usually I see that people who work with data science and are not data scientists, they usually overestimate or underestimate the time required to do something, which is normal. If you're not an expert in the domain, usually your estimation as to how long it's going to take you to reach something is going to be, off of the target. It can even be difficult for experts sometimes. So the next slide is very important because these are 4 quick heuristics to help you understand how a problem could be solved. And essentially we covered 4 different types of cases. Can something be phrased as a statistical modeling problem? Is it a hypothesis test? Is it a supervised problem? Or is it an unsupervised learning problem? Okay, and again, this is the job of a data scientist, but it's good to try and think like a data scientist. It will really help your understanding of the challenge and what you should expect from it. So, can it be phrased as a statistical modeling problem? Is variable X important for Y? What's the relationship, right? So this is when...
Hey, Nana, you all right?
Sorry? Sorry? Okay. So this is when you really need to use statistical modeling, when you want to understand the relationships between variables, and this is when you need to go for a statistician, or sometimes you might even be able to do this through exploratory data analysis. Hypothesis testing, another component of statistics, can help you with things like comparing groups or A/B testing, etc. Or if you're trying out different, in A/B testing we can either be talking about the commercial domain websites, or we can even be talking about medical experiments, right? So this is where you're going to do.
My name is Roy Fox. I'm a postdoc at UC Berkeley. Thank you all for being here. I'm going to tell you a bit about our work in deep hierarchical reinforcement learning. I'm going to unpack that a bit. And also about
the infrastructure
we've been using.
That's funny. Sure, yeah. Like YouTube arbitrarily decided that we wanted to hear more about reinforcement learning and set us off track. So where was I? I was talking about the heuristics. So let me go back. So where was I saying? I was explaining about statistical modeling and the hypothesis test. And I was giving you some heuristics as to when you might want to use this. Then supervised, then how can you approach a problem using supervised learning? You use supervised learning when you want to automate something that the human is doing. And this is the leading force behind automation, right? This huge wave in automation is largely driven by supervised learning in many cases. So if you have a human which is doing something and providing a trail as they're doing something. For example, labeling instances or making a decision like something is spam or ham, then this can be automated through supervised learning. You can also use supervised learning if you want to make predictions to the future. And finally, unsupervised learning is used when a data set is complicated and you want to extract insights. I gave you an example of customer segmentation, or when you're not even sure what you're looking for, you want to extract general insights, which is another very common problem, right? Ideally, as I mentioned earlier, you want to use, to have a challenge in mind when you approach data, but in some cases you might not, and you just want to extract general patterns. That being said, if we look at the different industries, and I can, if you want guides about particular industries, I'm more than happy to provide some guides for you. So if you're like, hey, I'm in manufacturing or I'm dealing with a problem in this sector, can you help me understand a bit better some of the applications in this sector? Shoot me an email. I'm very happy to provide some guides to you talking about specific applications. These are not some very high level heuristics, right? We're just trying to see things a bit from above. And then a few more heuristics. If you're talking about image or audio, you're looking for deep learning. Many solutions are not commoditized, so you can just buy them off the shelf from the cloud. Actually, not off the shelf, you can buy them software as a service. Then if you're in a B2C domain, recommender systems are very useful. Some other applications, chatbots, forecasting these days takes place through machine learning. If anyone is interested in this, shoot me an email because it's a bit of a complicated affair. And then there are some other some other issues to take into account. Sometimes a project fails, and there are different ways in which projects fail. Three very common mistakes I've seen besides data issues is that in some cases a project plan can be very vague, or a project plan or a business plan can be very vague or big, like we saw like some vagueness in some previous examples, like we're not sure what we want to do, or sometimes some grandiose plans are like, we want to predict everything, we want to create some system which does something insane. And this might sound a bit funny, but for example, the European Union invested some billions a few years back in order to build a system which would predict everything, right? I'm not sure who came up with this idea, it's very stupid, whatever. They fund this. And sometimes also hear startup ideas which are, you know, it's clear that some people do not even have data and they want to try and tackle a very big problem. And then maybe machine learning is an overkill, right? I remember advising a company that wanted to create a very sophisticated bot which could read your emails and figure out whether you want to set an appointment and blah, blah, blah. And essentially they wanted to develop a very expensive piece of technology, and the technology for this didn't even exist, for a problem that didn't really exist, right? I mean, people can just get a PA, right? I mean, what's the big deal? Or use Calendly, whatever. And you don't want AI for this. And then obviously, in terms of data, the quality, the volume, and the size are very, very important. I mentioned an example earlier of where things can go wrong, where I had to study a problem. It was like a problem around how, around understanding the differences in pay, in salary between the genders, but the gender was missing from the data set. So we had to go back and try to infer the gender from someone's name, and this was proven to be very, very difficult in practice, and we had to throw away lots of data. And this goes back to having the right data strategy, right? Having the right data strategy, and this is what we do with the Tesseract Academy, right? Preparing companies to use data. And the question is sometimes what's really the problem, right? Because sometimes decision makers think that they want to solve a challenge, but because they've not thought about the KPIs, they don't understand that this is not what they want to do. So for example, maybe you're going to predict the price of Bitcoin. This is what you say you want to do, but what you want to do is you don't want to predict the price of Bitcoin, you want to make profit, right? Which means that maybe you don't care about predicting the price, you care about whether the price is going up or down. Okay, just an example. And there are different processes for dealing with data science. If someone wants to look more into this and they want to follow a process in order to define a problem, more than happy to help you. This is a famous process by IBM, the CRISP DM, which now has been updated. I don't like the updated version as much. I really think this one is just simpler, which shows how different steps of using data are in how the different steps using data and applying data science break down, and what are the different steps to take. And we have 7 steps here from the beginning to the end that a business has to follow in order to use data science successfully. And you can see that the first 3 steps actually are related to the business, right? And if we go back to the process I shared with you in the beginning, I said that there are 2 actors, the data scientist and the domain expert. And the first steps belong more to the domain expert, who has to define a problem and understand the drivers and the KPIs. And then this process is slowly transitioning and putting more weight on the data scientist, right? Who has to uncover problems and code algorithms and measure the results. Again, this process is not like, the holy grail, but again, this process, like some of the frameworks I shared, like the data strategy canvas, some of the tips I've given you, some other tools which I'm more than happy to give you frameworks if you send me an email after the session, are there, not because you have to follow them to the letter, but because they help you understand how the different challenges break down. So for example, what the mistake many people are doing is they don't go through the first 3 steps and they call upon a data scientist to go straight to this, or they want to uncover business opportunities, but they don't understand the drivers, or they report the results, but they don't report the financial impact, right? So I've seen every permutation of these problems happen in practice, okay? And I've actually done some of these mistakes myself as I was learning. So any questions?
Hi, I do have a question.
Yeah.
You talked about heuristics and about supervised and unsupervised models. Is there a way to predict how big the training data set needs to be, or how long do you need to collect data? Like if it's time lapse data, like how long do you need to collect it for in order for you to get good results or good accuracy?
Yeah, actually, there are 2 ways to do this. One is obviously experience, so which means in certain domains we know what we need. Let's say a few thousand data points or a gigabyte or maybe a few points are enough, right? In general, for anything relating to machine learning, if you don't have a few hundred data points, it's not worth trying anything. If you have less than 100 data points, then you're usually dealing with statistical modeling, which is more efficient in extracting information from the data for small samples. And then there are some certain technical tools like learning curves, as we call them, which help you see, I mean, if you're a data scientist, it's a bit of a technical tool, but I can maybe share my screen to show you, which tell you how an algorithm performs as you're adding more data. Yeah. So,
and I guess it's similar questions with the number of variables, like how many parameters do you collect?
Yeah,
and which one will bring the most value? Is it part of learning curve as well? Like, how do you decide which parameter is the most valuable?
So, if you're talking about the total number of data points, then we use learning curves. If you're talking about variables, usually the problem is the opposite, which variables to remove. So why is this? Because if we're talking about data points, you know that you have a system in place which can collect data points, right? So maybe you have some users, right? Okay, thanks, David. Yeah, I'll send the recording. So you have a system which you know can collect variables, right? Maybe you have an app and each user generates data. So then maybe you want to ask me how many rows of data do I need before I can actually create a recommender system. So this is one problem where learning curves can help you. And you can use the learning curve and see that the performance of the model improves as you keep adding data, and you need to go up to 10,000 data points before you can use this. The variables, however, are defined by other factors, by external factors, so defined by the domain, are defined by what you can record, right? So it's not like you can just add variables on demand. So if you're in the medical domain and you're doing a blood test, maybe you record 5 or 10 variables. It's not like you can say, oh, I'm going to go back and I'm going to add 20 more variables for each patient. You know, it's not as easy. So usually the challenge we're facing with variables is that we're adding with companies or individuals or researchers that try to add as many variables as they can, and then they try to figure out how to clear out some of these variables. Does this make sense?
It does. I'm mostly trying to figure out, most of the times in medical devices, you have to answer those questions pretty early on because you're putting protocols together for research studies or something else, or clinical studies. So like what tools are there to use, and who would be deciding those things? Would it be the data scientist or the domain expert?
So I think it should be the domain expert, because the domain expert, in my experience, usually have a good intuition as to what variables might be predictive, but the data scientists can help give them ideas. So if you go back to the steps I outlined, the data science process outlined in the beginning, I say that there are two actors. The domain expert plays a larger role, but the data scientist also plays a role in this process. In general, it's better if there's not much cost to collect more variables and then use techniques from feature selection to figure out which ones are the most important, simply because you can't just go back and collect more, right? Because what I mean, for example, in the medical domain, if you want to collect more data points, then you can just increase your sample, right? And run another study. But if you're going to collect more variables, maybe you need to use a completely different device or method. And this is a more expensive choice most of the time.
Understood. Thank you.
Yeah, so that's actually a very good. That's actually a very good point, because I'm still advising a medtech startup, and they face this issue, right? Because they're using wearables to record various parameters like the respiratory rate and the heart rate, and these challenges are always there, right? Like we run a study, and then it's like, oh, was this data enough or not? And should we try to do more signal processing to create new features from the existing data, or should we just collect more data points? This is always a challenge that is there. But if you think about the cost benefit, really just go for more variables if you can, and then and then try to figure out how to clear them out. I guess the interesting thing behind medical data and medtech is that you're dealing with lots of expensive and time-consuming stuff, right? Like creating protocols, finding subjects for the studies, etc., etc. But happy to talk about this in more depth as well later on. Yeah, so now some pitfalls. I'm going to present you an example of where sometimes things can go wrong. What you shouldn't do is you should be able to understand the problem like a data scientist, or try to think like a data scientist in order to facilitate this process. But you should be able to delegate, right, as well, and trust the data scientist to come up with a solution. So this is an example of a bad collaboration I had in the past. We solved the problem in the end, but there were quite a few challenges along the way. So this was an app that was rewarding users for making some for taking some steps to improve their health. And so who's this person? And there are a few different ways to solve this problem. Essentially what was available at the time was data before someone had installed the app and after they installed the app. And we wanted to see whether installing the app actually increased their activity levels as measured by the total number of steps. And there was a statistical way to solve this, but the problem is that the people that had hired me to do this, they didn't really understand what the statistical model was doing, which is fine. I mean, they're not experts in statistics, that's fine. But then again, they really wanted to prove this, and in order to prove this in a scientific way, then you need to follow a certain methodology. And then they tried to come up with different suggestions to solve this problem in a way that these suggestions weren't really scientific or robust or something that someone would publish somewhere. And essentially, I'm going to quickly skip over this. And essentially, the problem existed from the fact that while they wanted to prove this in a scientific way, at the same time, they wanted to to show something to investors which would convince them that this is worth their money. And these were two very, very different things. And in the end, the solution was that we had to use one model for investors, one presentation for the investors, and another model internally. But we spent some time, some months during which we went through these like different suggestions which didn't really lead to anything. And the problem here was that these people were not ready to delegate. They just had their own ideas and biases, and they just wanted someone to confirm those biases. And when you deal with a situation where you need to shoehorn a solution to a problem, then you end up with many, many issues. And data science and science in general can be a very complex endeavor. And these are one of the challenges you're dealing with. We already saw many of the challenges, from biases to corrupt data, etc. And if you just try to simplify everything as much as possible in a way that everyone could understand it, that it's very likely that you're doing something which is just not right. Okay. And I have this image here about, vaccination and pharmaceutical studies. And again, these are like very complicated things. People have their own opinions, but in the end of the day, and also this goes back to actually practicing data science. If you really want to understand what's happening, there's no way around studying this topic in depth. So that being said, the mistake here was not that the decision maker didn't really understand data science, but they didn't feel comfortable enough with what they were doing, to the extent that they would delegate this to someone, right? And again, this problem really took place because of the lack of data strategy, because this problem would have very easily been solved if there was a proper data strategy in place, so that we could have used some more common methodologies in order to approach this problem. Usually most of these challenges, as you might have realized by now, they show up because of things like the lack of preparation or the lack of data strategy. Any questions before we move on? I think we're pretty much on time. Maybe we're going to overrun like 10 or 15 minutes, but we're pretty much on time. Okay. Let me go back and show the last presentation. So give me a second. Okay, and now we're moving on to the last two sections, which are shorter. One is about hiring and managing data scientists, and the other one is about building a data science culture. So for those of you who want to hire a data scientist to work with them, here are some tips. First session is about what makes a data scientist and what motivates a data scientist. And there is this very famous diagram called the data science Venn diagram, which says that data science is essentially a combination of three different things, right? One is math and statistics knowledge, then hacking skills, as they're called, which this refers to coding skills, but coding on a high level, not super like skillful, and then substantive expertise in a particular domain, okay, which is the domain knowledge. So when you have all these three, you have data science. If you have expertise and knowledge of statistics, you have traditional research. If you have coding skills and statistics knowledge, you have machine learning. If you have hacking skills and expertise, then you're in the danger zone, which exists when you think you know something and then you just download the library off the internet and you run an analysis and you get some results and you think the results are correct and they're actually not, okay? Which is something which happens, which can happen in practice. So what motivates a data scientist? Data scientists are usually curious by nature. You see this a lot with workers in tech, and quite often they chase interesting problems, and they like to learn new things and acquire new skills. And this is actually something integral in today's job market. So you see a lot of people moving around in order to acquire new skills all the time. Data scientists, like most people actually don't like repetitive work or boredom. I guess data scientists are a bit special in this regard because their job quite often can involve some boring tasks like cleaning up data, and which can also be a bit repetitive, which is a bit funny because on one hand, it's a very advanced profession, let's say intellectually. On the other hand, some of the things you have to do are pretty boring. And then also data scientists, and again, this probably many people in tech can relate to this. They might not be the most communicative people, even though communication is an important skill in data science. And issues with the culture of a company that cause friction in communication can be very, very bad. In general, data scientists are still in a buyer's market, so the demand outstrips the supply, and they're more in a position of power when choosing a job, right? So what the data scientist is looking for in a role. So the compensation is a no-brainer, but then we have the team, the problem, the technology stack, and their relationship to academia. And the team goes without saying, everyone likes to work with people that they like, but I think data scientists, like again, many people in tech, many of them appreciate things like more informal culture, working from home, etc. Then the problem, many data scientists, they have a bias for particular types of problems. That is, they like to, maybe they like problems in particular domain or with particular methods. And quite often it's about learning how to do something new. And then the technology stack. So some people are biased and they want to solve problems using specific tools. But then again, maybe some of them, they like learning something new. And some people might be willing to learn something new in order to also improve their job prospects. One of the problems with hiring data scientists is that quite often data scientists are trying to work on new things in order to improve their skills. But many data scientists are, and sometimes companies are looking for experience in the domain, but data scientists quite often are looking for something new in the domain, right? And something important to understand is that data science is a general tool. And this means that the same algorithms can be applied in, let's say, predicting a disease or in marketing. And so you don't have, I mean, obviously knowing a domain is very useful, but you don't need to worry that much about it. If you're a domain expert and you've been in a workshop like this and you feel comfortable in communicating the domain and its requirements to a data scientist. I think the breadth of knowledge can be more important than the depth, because if someone has a very large breadth of knowledge, then they can deal with many topics and they can always find an answer for something, right? And one of the challenges that many data scientists, this in general, you see this in the job market, people sometimes are very quick to judge others and think they have over-specialized in the domain and that's the only thing they can do. And this is just not the right way to approach things, right? So maybe you are working with someone, you're talking to someone who has experience, let's say in time series, which can be applied in many different domains, and you think that you can only do finance, for example, right? And obviously data science is one of those fields where talent can play a role, and it's very important to hire young people if they're talented. And it's good to try to not miss out on junior data scientists if you're building a new team. Something else that's important to state is that many data scientists are still coming out of academia, and they like to they like to stay in touch with academia, and this is where this can be an extra incentive to go to conferences and learn about new techniques and methods. And obviously another dilemma, these are like some conferences, famous conferences if you want to look them up. And then another dilemma is obviously that data scientists, they're not sure whether, many of them are not sure whether they want to go and work in a bigger company or a startup. And essentially, this is a problem that exists again with many tech workers, and really the decision comes down to someone's, I guess, not only compensation, but also to the personal goals and preferences. Something important to note is that you need to stop hiring data scientists until you're ready for data science. You need to make sure that your company has a data-driven culture, which we're going to cover in the next session. you need to have data available, which we covered in the previous sessions, and we need to make sure that there are the right channels so that the data scientist's work can have an impact, okay? And then in terms of mistakes, you shouldn't use data scientists only for reporting. They're not business analysts, they're data scientists. You need to be able to delegate to them and have them take new approaches to problems. And I've had real stories of companies hiring data scientists and then not knowing what to do with them because there was no clear goal. And on the other end of the spectrum, we have Booking.com, which is one of the best companies in building a data science culture. And we're going to mention this again in our last session coming up in like 5-10 minutes. Any questions so far? Okay, then I guess I can move on. And I'm going to now talk about what I call the data science tribes. And these are the different types of data scientists in case you want to work with a data scientist. So there are 3 major tribes and 3 smaller tribes. So the major tribes are the computer scientist, the statistician, and the quantitative specialist, right? So I'll actually go straight into the description of each tribe. So the computer scientist is by far the most common type of data scientist which you're going to encounter. And this is a person who has done a computer science degree and then they specialized in machine learning, either through a master's or a PhD. And these people are very good, have very good all-around skills, and they have solid database skills, solid skills in machine learning, etc. But usually they lack formal education in statistics, which can be very problematic when you actually need a statistician. And statisticians are the opposite. They've studied statistics with a first degree, and they have very solid knowledge of research design, etc. So for example, the medical domain statisticians are very useful, but usually their skills in coding or things like databases are not that great. So, and also many of them might not be that great in things like predictive modeling, right? So statisticians are very good in some domains, not so good in other domains. Whereas machine learning people, computer scientists are better when you care about predictions, computer vision, analyzing audio, deep learning, this kind of stuff. Where statisticians are good for studies, right? And then we have the other quantitative specialists, which is like a Wild West with alien who's taken a boot camp and they've transitioned from being to an accountant or physicist to being a data scientist. And really, I don't know what to say here because it's a bit of everything, honestly. And something to be careful with is to avoid people who are faking it, but give an opportunity to smart candidates that are willing to learn. And then there's usually a convergence point, where people who have a certain number of years of experience, they've seen a bit of everything. And at that point, they know that they know enough things so they can deal with many different, challenges. Not because they know everything, but because they have a very good map in the head of how to find the solutions of the right algorithm for the right challenge. And then we have what I call the smaller tribes, which are people who are not really data scientists, but they're trying to get there. Like, for example, you have people who are self-taught by doing things like hacking competitions. Then you have people who learn how to use tools like software platforms. And then you have people like what I call the domain specialists, which are people that have specialized only in a certain part of machine learning, like computer vision or analyzing audio or deep learning or something like this. Yeah, in general, these types are not as useful. I mean, the first 2 types are useful for business analytics. The third one is useful if you are actually facing this particular problem. So in this case, if you're talking to someone who's done computer vision for the whole career, then you want to go for, and you really face a computer vision problem, you want to go for this person. And so I'm going to skip over this and I'll move on to the last session. As we're more or less in time. Any questions so far around hiring or the tribes of data scientists? Okay. Does everyone see this? Yeah. Okay, and now this is the last session. And I'm going to talk about how to build the right culture for data science. And if you're interested in this topic, then I'd urge you to watch the film Moneyball, which is really a film about building a data-driven culture. It's not so much about sports. Very, very interesting field. And if you want to build a data science culture, it breaks down into three things, right? Management, employees, and the organizational level. So for the management, it's about being rational versus being gut-driven. I'm going to explain the differences between being data-informed and data-driven. On the employee level, it's about creating a friendly environment for data scientists. And then on the organizational level, it's about being data-centric. Okay, and I'll explain what all these mean in a second. So data informed versus data driven. So you're data informed when using data as an input for decision making, and you're data driven when you let data decide. And the opposites are intuition-based decision making and tradition-based decision making. So many organizations these days are data informed, and this can be as simple as having a dashboard or an Excel. And if your data is collected from multiple sources and then the data is organized and documented, then you're data informed. But you're data driven when you trust an algorithm to start making decisions for you. So this is when you use a recommender system. This is when you are using an algorithmic trading system, right? So data driven is very closely aligned with automation. And this is the goal of many companies, but there's a warning there that because you're trying to become data-driven, this is not necessarily a good thing. This is a very good quote by a guy called Eric Peterson, who used to be Accenture's chief scientist, and said that data is a double-edged sword. And why did he say this? Because data, when it's properly used, it can lead to very good decisions, but when it's not properly used, then it might lead to false decisions with a very high degree of confidence. And this gets us back to the danger zone, right? Where many, unfortunately, many people make the mistake and they fall straight into the danger zone, right? So creating a friendly environment for data scientists, this is what we discussed earlier. It goes without saying for any organization, that's very important. And then becoming data-centric is when data is at the core, as we'll see about Booking.com. So this is when data science is treated as a separate division. At the same time, it is integrated into the processes of a company. And this gives more freedom, but also more responsibility. And this largely depends, the effective application and creation of a data-centric culture largely depends on the right communication and reporting channels between different departments and the data scientists. And it's very important to make sure that these channels exist so that everything that gets collected is also implemented. So here's an example of when data is not at the core, right? So this is a very common bad example that the company wants to hire data, they want to use data science, but instead of hiring someone, they try to do things internally using software developers. And the software developers do not properly understand what they're trying to do. The model goes into production and the results are disastrous, right? Because they use the wrong testing scheme. Another common problem is when things are not getting implemented. So you have a data scientist who is not familiar with the domain. They have complete freedom to work with the data, and then they create things without taking into account how the data, how this will actually be valuable for a company. Very often, it happens very often with people coming straight out of academia. Another issue is that between departments, maybe you have different styles of communication, and especially between developers and data scientists. And sometimes you see things not being implemented or not really being able for the data scientists to communicate what they want to deploy in the right way. And this can create lots of friction. I've personally been there for example. So this is where it really pays off to have developers who really understand how to work with data scientists. Any questions? Okay, if there are no questions, then I'm going to move on to the final session. And we're going to talk about how to build this data-centric culture. And the first thing to answer is why you need data science in the first place, right? And the most common scenarios for business is that data science is an integral part of your business, which this is you run an AI business, or you want to improve efficiency, for example, in operations, or you want to improve sales by increasing margins, for example, or using something like a recommender system, right? And this is the first thing for you to define, right? Why you want to do this. Okay, this is very, very important, and this relates to the KPIs and the things we discussed earlier around using a data science process. And then there are some obstacles when someone tries to build a data-centric culture. One is resistance to change. And resistance to change can be intellectual, personal, and cultural. And cultural is we have always been doing things this way. Okay, then the personal is when you're dealing with employees and they don't really see the benefit in using this type of, in going through this, through this exercise. And then the intellectual is when people don't even understand what this is. So the resistance to change, as I mentioned, cultural resistance to change is very, very common. This usually exists with old and big organizations that have multiple layers of management, okay? And especially in fields that they never had to do much with numbers. So for example, I had done work in sports, and sports is like 15 years behind finance and this sort of things. Then personal resistance to change takes place when an employee does not really see the benefit in doing business with you. So they've been ordered, let's say, by the management to do something, but they don't really see why they should go about doing this, okay? And I have been in a case where project was delayed by a year because of that. And then the intellectual resistance to change exists when someone doesn't even understand why they need this. And usually this is where thought leadership can help change the minds of decision makers. I think that now in the world of AI, we're beyond the point of intellectual resistance to change. I don't think there are many people who are like, oh, I don't understand what this is. I don't understand why anyone is using it. And when you want to take this journey to change and become data-centric, you have to help the data scientists get you there and create a data science-friendly environment. And ideally, if you want to run projects with a large impact, obviously you want to have you want the projects to be impactful, but also you want to make sure that that the employees, they see that the projects are impactful, right? And this is where a champion can help, which is going to be the next slide, who can help drive this effort and also focusing on the benefits for the employees, right? Instead of just seeing this as more work as many times they do. So then the champion is a higher ranked employee, and usually in every situation of this kind, you want to have a champion, if you're talking about the bigger organization, who is someone who has the enthusiasm and the status to drive this effort forward. And this could be you, but it could also be someone else, like a chief data officer in an organization. Okay, ideally this works better if there's someone already in an organization. And employees need to see this as a learning experience for them, right? Very, very important. And then there are two ways to start. There's the baby steps approach, as I call it, and the use case approach. And the baby steps approach is by taking small steps and taking it one at a time. And then the use case approach focuses on a single problem and tries to work around this problem, and then through that slowly adopt AI. So the baby steps approach is the most common approach. And this is when a company is interested in data, but data is not the priority. So the pros is that this is not too disruptive to current operations, but the problem is that you don't have a specific goal in mind, which means that the data might be organized the wrong way. The use case approach is less common, but I think it's a bit better because a company is focused on a single use case, and in doing this use case, the process of of trying to go through this use case, they end up setting up all the systems required in order to accomplish the objective, and then they lay the groundwork for other projects in the future. And quite often companies start with a baby steps approach, and then they go on to the use case approach. So some good starting points are to map your organization's use of data, to emphasize strategy and innovation, to reward good behavior, and to create an embedded culture. Okay, so all these are some very good steps in starting with building a data-centric culture. Using dark data, if you work in a big organization, is something which is often overlooked. This is data which is not being used, but could potentially be very, very useful, like log files, CRM, notes, emails, etc. And dark data is actually a huge part of the data space, maybe the biggest, and this is largely created from the fact that many systems are passively collecting data, but the data is not being used. And this is where you end up with like data lakes and data warehouses where, you know, the people are just throwing data and they don't know what to do with it. And there are many, many use cases of what dark data can do, right? From extracting visitor behavior from log files to extracting sentiment from customer calls, many, many things. Then some of the other steps which I mentioned that you can take, again, this mostly applies to bigger organizations and SMEs, to create a culture that promotes strategy and innovation. And this is where Champion can be very, very useful asset. And there are some other ideas like internal hackathons, allowing employees to play around with the project, using Kaggle for internal competitions, and open some of your data and inviting others to participate in small projects. All these are very, very good ideas. And then regarding good behavior, that's also very important. So for example, the Google Research blog, the Facebook Research blog, these are some very good blogs which where employees in the research divisions of Google and Facebook respectively, they publish what they're doing. And this helps the people involved in this research to also get some recognition, which is very important, right? And the final step is to create an embedded culture. And this is where, this is about data scientists working very closely with developers and product owners. And promoting communication is very, very important as well in this case. And it could be stand-ups, could be some other way to do it, you know, now like Slack, like different methods of communication channels. And creating a mentorship program for new data scientists can also be a very important way to nurture talent and create this embedded culture. And once again, I'm going to refer you to this case study of Booking.com. And Booking.com has created really an embedded culture where all different data scientists are closely integrated within a business, and there are different teams working very closely together, right? And they expect that data scientists, they're not only doing data science, but they're also excellent in communication and commercial awareness and other topics. Again, this is a very good blog post. If you're interested in this topic, I would urge you to go and read it. And actually, let me share this with you now. Sorry, let me share chat. Yeah, and yeah, that was it. Any questions, any comments? Obviously, I'm planning to follow up with all of you. I'll share you the recording. I'm also planning to show you the deck of slides and my book for those of you who don't have it. But yeah, any questions about this session or pretty much the workshop? Okay, no questions.
So no questions, just an observation in terms of the culture you're looking to create.
Yeah.
It takes a long time to create a culture, and it takes baby steps. So in terms of organizations, if I look at my personal experience, lots of them are very sales-led, and they go through a maturity process. So bringing on data scientists, bringing on processes and policies, all of that does take time. And the key thing is where it matters. influencing the right people and the stakeholders to make sure that things are adopted at the right time?
Yeah, I think the most important factor is the size of the organization, I think. So if you're talking about a very big organization, it's quite possible that the change might start taking place to the middle layers. We have people who are somewhat experienced, but they're not too old. If you're talking about something like a scaling organization with like 20 employees, 30 employees, then things are probably much easier, right?
I typically work with organizations where there's between maybe 60 and 200 employees. Mm-hmm. And even then there's a culture which is very much sales led. If I look at my problems around AI and the businesses I work with, they have very good products. They have very good solutions. Internally, they take on developers, they take on salespeople, and they try and build their business bounded around sales. So you get to a point where regulations apply, and you get to a point where they need to start maturing. And the challenge that you have is they're very much sales led. So there's a bit of friction and, shall we say, challenges around changing the culture to make sure that it's appropriate to the needs. So from a data science perspective, you need the data science, you need the operations, you need the infrastructure, and you need the sales. And in terms of importance, at certain times, some are more important than others. So taking product as an example, if the data science isn't right around the AI, then the product is not right. Taking the sales perspective, if they're not selling it, then the data scientists aren't achieving their aims and delivering what they need to do because of a lack of investment. So it's a push-pull, but typically between 60 and 200 employees, which is the sweet spot where I work, it does make an interesting cultural balance because there's always challenges there, and it takes many, many months, if not years, to change those cultures.
Yeah, that's a very good point. And I guess maybe, you know, a company is more sales-led because this is what they needed at that point in time. But then it's, you know, but then it tries to transition to different priorities and objectives. And, you know, cultures are very dynamic, right? They're not easy to change overnight. So I think that's a very good observation, 100%. And I'm sure if there was someone here, for example, who could work with even bigger organizations, they would probably provide some of their own inputs. I actually have some experience with more like with startup scale-ups and some very big organizations, but not so much in the in-between. I don't know why, it just happened. And this is what I had noticed, that when I was working with very big organizations, it was like the middle layer that would really interact with me.
Yeah, I call that the treacle layer. So you have a direction from the top, and you have people who are doing what they need to do from the bottom. And then you've got that layer that are trying to navigate all of the challenges and problems. Communication is an issue, strategy is an issue, and then product's an issue. So I think that these are all, shall we say, common organizational issues. But what I see, particularly when I deal with data scientists, is within an organization, they're very well organized. They have their structures, they have their processes, they have their policies. And then it's the interaction with the stakeholders that brings the most challenge. And that goes to what you're saying, that middle layer, what I call the treacle layer.
Yeah, very good point.
I like that phrase, the treacle layer.
That is a good point. So cool. I'm not sure if there are like any other comments, but as I mentioned, hopefully probably tomorrow or a weekend the latest, I'm planning to follow up with all of you. And again, I said like the data strategy canvas. If some of you want to use this or some of other frameworks and they want some feedback, you know, more than happy to provide this. If you had some questions which, you know, maybe they just arise in your mind tomorrow, again, more than happy to help. So it's not like because the workshop ended, the work is ended. So yeah, I'll make sure to follow up with you within the next few days or so. And if there are no other questions or points to raise, I guess we can conclude.
From my perspective, I found it very interesting. Thanks for sharing your thoughts and ideas. And yeah, I've got some ideas to take away and tools to put in my toolbox. So thank you. I enjoyed that.
Oh, perfect. Yeah, glad to hear this. So yeah, I'll make sure to follow up. And as I mentioned, we're also planning some other events. We want to start planning some more events on specialist topics, like maybe algorithmic bias, transparency, ethics. There's some AI ethics frameworks that started to be released. Yeah, feel free to join us.
Thank you.
Great. So thanks everyone. Have a great evening, a great afternoon if you're based in the US, hopefully I'll be seeing you again soon. Yeah, thanks everyone.
Thanks, Stelios.
Bye.
Thank you a lot. Bye.
Chris?
Yeah.
Oh, you there?
Oh, Billy's here as well.
Billy seems to be